This is just a live stream today where I'm going to be doing work with Blender and GPT. I'll be making a documentary probably for the next day or two, and I'm just going to make some simple animations and whatnot, so I'm just going to start working. I already put together a lot of material for this. I spent about a night writing out a documentary that I wanted to use. See if I can bring that back up. It got closed. Okay, I have to go into a different screen really quick because I gotta fix this now. Well, I can't see it, so that's unfortunate because I just set it all up. This program makes me furious sometimes. Just do it live, I guess. Really furious because she did all this. Okay. This is probably how I'll have it. I just want to have GPT up on my screen so people can see it. So, I mean, I've been curating a little thing overnight. I'm going to be using this Google Translate to read for me, and then I record it. I don't know why they put it online if it... I don't know why they put a little demo spot. They didn't expect people to do this. So, my workflow is just using GPT to write some documentaries for me based on stuff it knows and stuff I found with their new data analysis. Their new data analysis technology is pretty cool. So I've been using that. Data analysis allows you to upload files to GPT, and it's really actually amazing. Let's see. Now I'm streaming and I can't think about what I'm doing. So, I gotta start with what I've already worked on. So basically, like, my workflow is this. I made a bunch of segments for my documentary I want to work on, and I like to load them in here and get a scope of what it sounds like. And I've been using the polygot, and like a pitch of -4 is pretty good. Like a speed of 1.34 is pretty good. This is what he sounds like. Pretty convincing.
Black holes. Are they universe's ultimate destroyers or hidden creators? What phenomena occur at the edge of an event horizon? Is it possible for anything to escape their gravitational pull? And what might lie at the heart of these gravitational monsters? Let's delve into their darkness, seeking to understand the cosmos' most captivating riddles. Imagine a star with a mass exceeding 5 times that of our Sun. At its core, hydrogen atoms fuse into helium, releasing energy, billions of megawatts, radiating as light and heat. This energy exerts an outward pressure, counterbalancing the star's gravitational pull. Over time, the star depletes its hydrogen and transitions to fusing helium into heavier elements, each stage creating less energy until iron accumulates in the core. Iron fusion is endothermic, absorbing energy rather than releasing it, which disrupts the delicate balance of pressures that sustain the star. Fusion halts because iron's nuclear binding energy is at a maximum. Heavier nuclei would require rather than release energy to form. When the iron core reaches about 1.4 solar masses, known as the Chandrasekhar limit, it can no longer support the star's outer layers. The core collapses within seconds, temperatures spike, and a series of rapid nuclear reactions occur. These reactions do not result in the creation of new elements but instead lead to the production of neutrinos and the photodisintegration of iron into helium nuclei. The core becomes so dense that electrons and protons merge to form neutrons, releasing a flood of neutrinos. This sudden burst of neutrinos carries away energy, causing the outer layers of the star to rebound in a collapse.
And so that's basically it. So when I'm gonna go record, I'll just record the segments that I need to work on, and then I put them into Blender and I start working on them. But it's kind of hard because things are long, so that's why when I made my documentary, I set it up in segments. So I have like 11 segments, and when I come to each one, I can tailor it. I just wanted to see what it sounded like with more, but this would be like the size of a segment 1.
Black holes.
It's the same thing.
Are they universe's ultimate destroyers or hidden creators?
But it's a little shorter. And I tailored this part in here. When I got it from GPT, it wasn't like this, and so I had to add commas and periods for punctuation. And now it reads this way. And so, like, for people that don't like this, too bad, you know. It's a really fun way to fast forward to what you're trying to do, because I've always wanted to make a documentary, but it's kind of a lot of work. So I'm gonna start with this segment. Another thing that I was trying to do was put together a repository for images. So actually I need to do that first. So if I go back to my black holes multiverse theory page, then I think I already asked for it. Black holes in the cosmic landscape, misconceptions about black holes. Okay, introduction to mysteries of black holes. Briefly introduce black holes as a cosmic and as enigmas. And okay, I have somewhere I asked it for links to scientific websites that contain images of black holes. Oh. Oh, maybe this is it. No, this is not. I don't know where that chat went to. I don't like when I lose chats. It's supposed to... I already asked for a chat with all the images somewhere. I think I just wrote over it. just ask again. Yes. But I have this awesome add-on. But you can't see that. Why is that? What's going on here? Oh, that's why I had to do it twice, because that's not even the right one. Ah. You gotta love Streamlabs OBS. Oh man, I love Streamlabs. Okay. I haven't even been streaming this whole time. Sorry guys, this just... So, here's GPT. And I've been asking how to make a universe documentary. Like, I want to make some about black holes, so I've been doing a lot of research, and I made a couple repositories filled with information about black holes. And now I just need some more factual images. So I'm gonna use like my long history here, and I also have like a a JSON file, JSON file that I have prepared. And let me see if I can bring that up. Like my screen capture. Hold on. Screen. Scene? No. Display capture. That's what we need. Okay. Look at that. Like, what great technology. Okay. So here is this window that I have made. And here's my file. Okay. And so you can see I have documentary segments about black holes and about black hole documentary. So this is like my history from all my chats. So if I bring it up, you can see that it's a very long run-on of like just tons of history. And now GPT can understand this, right? You have to put it in a JSON file, or at least that was yesterday. I don't know if they've updated it. They're doing crazy stuff, so it might take like pretty much anything now. I thought it would just take basic text files, but it was struggling with that. But this is working for me, the JSON file. And it's like about black holes, so this is about 6 different articles, and I got some from Wiki about black holes, like everything. And you can also give it images, so you can't, I mean, you can give it, the thing is it only takes about 10 files at once. So you can take images and put them into a text file of some sort, like a PNG or a Word document. And then you can upload that to GPT, and it will see all the images inside the file. So you can upload like probably as many as you want. I think there's like a 100 megabyte cutoff or something like that. But that's a lot of information. So right. So I'm gonna give this my about black holes, so it knows more about black holes. I've already given it this many times, but just to re-jog its memory for this prompt. Like, And so now I'm gonna type, or I'm gonna talk to it with my little add-on, my Talk to GPT add-on, which is a very cool add-on for GPT, and it's already changed my opinion. Why does it do that? Why does you do that? Let me fix it. Okay. A lot of screens here. So the display capture, so I wanted to show that. I guess I will leave that over here for now. And so I have the file in here, and I'm just gonna tell it I want some pictures. Or not pictures, but links to some good images. I am trying to find some links to images about black holes. Sometimes you have to refresh it. This thing doesn't work very well. I'm wondering if it works better on a different platform, but they even said it works best on Google Chrome. Sometimes you have to like come in here and press save, and then it will hear you. Or you have to press this and then press save, and it will hear you. So, okay, if that happens, it doesn't work, you just have to reload. And just drop the file back in there. And just press start. I am trying to find some images of black holes. Please find me some images about black holes that are very scientific. Diagrams and accurate representations. Find me links online to these images. Find me 10 links to different websites with very accurate black hole representation art. GPT magic. You can set your own little like commands, so GPT magic is how I make it go. And so it will look for this. It's going to NASA. I'll be right back one second. Yeah, it's going to NASA, and it's going to go to a bunch of... Just find me like links. It's pretty crazy. It's pretty nutty.
Here are links to various resources where you can find scientific diagrams and accurate representations of black holes. NASA visualization shows a black hole's warped world. NASA Gov offers a visualization of how a black hole's gravity distorts our view, with matter collecting into a thin, hot structure known as an accretion disk. NASA Scientific Visualization Studio SVS. GSFC. NASA Gov provides a gallery of visualizations and narrated videos about black holes, including stellar mass and supermassive black holes. NASA's Black Hole Orally NASA SVS presents a visualization of known black hole systems in our galaxy, with scaled representations of their orbits. Scientific American, new image of an iconic black hole. Scientific American discusses a new view of a supermassive black hole enhanced by machine learning. NASA Science, Black Hole Science. NASA Gov provides an overview of black holes, describing them as huge concentrations of matter packed into very tiny spaces. Wikipedia, Black Hole Wikipedia. Org, https://n. Wikipedia. //www. Science News. //www. National Geographic. Types. Pictures. And Facts Britannica. Com, https://www. Britannica. Harvard. Edu, https://web. CFA. Harvard.
Okay. You can also turn off and on it reading certain things. So, I shall start going to these sites. 404. I hope nothing... Here, let's turn this off for a minute. turn this off. We'll just change scenes. There you go. I will check these really quick. Going to this NASA one. Pretty cool images, I guess. Videos. These are videos. Like turning black holes into dark matter labs.
Absorbs light, but so far no one knows what it is. Dark matter neither emits nor absorbs light, and it interacts with the rest of the universe primarily through gravity. In fact,
So these are
it's
images.
thought dark matter traced the initial framework of the cosmos, attracting normal matter that formed stars and galaxies.
Okay, I'm interested. What is this? What is this? What is this? What is this? View API. Oh boy. Wow. Wow. View full credits. Editor animators. Oh wow. This is a great website. This is NASA. Oh. Oh. So you can copy all this and put it in a repository. Like, let me show you what I mean. Okay, so you can just use something like WordPad. Like literally WordPad should be good. Let's look if I can add WordPad. Window capture. WordPad. Okay, so here's WordPad, and I'm just gonna make this a little smaller. And so I'm going to take, I wonder what happens if I copy this as a copy of the image. Looks like it does. Looks very convenient to me. So you would copy this, copy, and come to WordPad and paste it, and it gives hyperlinks. I don't know if that's the worst thing, because it's actually it doesn't give anything. So you're gonna have to be a little more tedious. That's fine. You're just gonna have to copy down to the image, paste it, enter, and then download this image. Looks like you can download a link to the media. That's cool, so I'm gonna put a link in here, and then space, and then download the image. Looks like you can download it in 7K, which is way bigger than we need, the smallest one possible. Okay. Okay, it didn't work. So download this. I guess I just save it. Save. Okay, and then I mean you can just copy it honestly, and then come over here and paste that. No, it doesn't look like it's very good. Well, that's fine. You can probably do a bigger one, maybe. See about maybe downloading the oh, that was 1920 already. They're all out of order. TIFF, PNG. We want a PNG. They're all out of order. Oh, here we go. I know. JPEG, 7K JPEG, 6 megabytes. That might be worth it. We'll go with that. because it's super clear and it's not very big on memory. I do want to see though if I actually download it and then I okay, and then I drag the actual image. Yeah, it's much better that way. Now this is off topic. I'm not even really working on anything right now, but I'm just exploring possibilities of GPT. I've been stuck doing it. And so I'm going to copy this, even credit to NASA, because then it can understand where that image came from. And then I just do that again. A hyperlink, put it in there, space, download. Looks like this one's smaller. Do the JPEG, save, and then you come grab it, pull it over here, grab all this information, that, well, let's then just get this one, because this one looks like the right one. Just delete that, and then pull this one in. Okay, and so we just do this until we're done, and this is how you like build a repository for, oh, we're done. Okay, so like that's that. So just to get this done, like this could be, you know, a piece of information that you can give it. So you save it as, and then save it in your file, and I'm gonna name it Turning Black Holes into Dark Matter. Save. And actually, I don't even know this. Like, if I upload a video, can you watch it? Oh.
No. I'm unable to watch videos. However, if you have questions about the video's content or need a transcription or analysis based on the video script or dialogue, you can share the text with me, and I'd be glad to help.
Okay, so that sucks. Maybe not yet. That would just be overpowered if it could do that. I'm sure the deepfakes are coming. So this is what I'm gonna do. This is just for fun, but I want to see how it reacts to this thing I made. I'm gonna drop the file into GPT that we just made. And then it's like loading it. And I'm just going to ask it to tell me about this file once it loads. There, it took a while, but it's a lot of information. Tell me about the file I uploaded to you. See, it's gonna be weird, so I'll type it. Unless we can fix it. Tell me about the file I gave to you. Tell me. Okay. It's a bug. I mean, it's just a bug. So, tell me about the files I uploaded, explain the contents, and the images. Okay, so it didn't read the file. I don't know if there's a problem with it. I'm gonna reload. And then I'm gonna try and upload this again. It could be a problem with memory. It's 206 megabytes. I might try and export it as something smaller. An XML document. Which is 0 bytes? No, that can't be possible. Okay, well, let's just exit that and then see if that works. So it took it. Let me give it the same prompt. Reading documents. Okay. It's not going to read it. We can just turn that on and wait a second for it to finish. I've been learning some bugs with this. So if you come up here and you press this thing, once it's done, it'll start reading again. You have to press this. Like, it's just kind of weird. I have to reload it. Start. Whatever. You're supposed to read it. Ugh, it's frustrating. I'm gonna redo it. Okay. Redo the last message. Redo the last message. GPT magic. It's like bugged out. Like it won't. Yeah, to the point where I'm mad. Like I'm not gonna do that. I'm gonna open it back up and try again, because oh. Okay. Yeah, no, I'm just gonna actually redo the whole thing. That no thanks. I'm gonna give you a file, and I want you to read the file. Hello. It's because they updated it. I'm going to give you a file, and I want you to read it and explain to me the contents and the images. Tell me when you want the file. GPT magic.
Please go ahead and upload the file, and I'll take a look at its contents and explain them to you. The document you provided discusses a new computer simulation developed by Jeremy Schnittman, an astrophysicist at NASA's Goddard Space Flight Center, which tracks dark matter particles in the gravity of a black hole and the gamma rays produced when these particles collide. This simulation aims to understand both black holes and dark matter, which makes up most of the universe's mass but is not directly observable. The simulation uses weakly interacting massive particles, WIMPs, a leading candidate for dark matter. WIMPs can annihilate each other when they collide, converting into gamma rays, which are the most energetic form of light. However, these collisions are rare under normal circumstances. Black holes can act as concentrators for dark matter, where WIMPs are forced together, increasing the frequency and energy of collisions. This effect is related to the Penrose process, identified by Sir Roger Penrose in 1969, which describes how energy can be extracted from a spinning black hole. Schnittman's model tracks hundreds of millions of dark matter particles and their collisions near a black hole, revealing that gamma rays with much higher energies can be produced and escape than previously thought. This provides a potentially detectable signal for gamma ray telescopes. The document includes images from the simulation. The first image shows multiple frames layered to increase the visibility of dark matter particles, depicted as gray spheres with shaded trails indicating their motion. The trail's color denotes how much the black hole's gravity affects the particles, with redder trails indicating proximity to the event horizon. The ergosphere, where all matter and light must follow the black hole's spin, is shown in teal. The second image illustrates the gamma ray signal produced by dark matter particle annihilations. Lighter colors represent higher energies, with the highest energy gamma rays originating from the crescent-shaped region near the black hole's equator and event horizon. The gamma rays with the best chance of escape are produced on the side of the black hole spinning towards us, showing an asymmetrical emission typical for rotating black holes. These visualizations help astronomers and physicists better understand the interactions between black holes and dark matter, potentially opening new avenues for observing and studying both phenomena.
Okay. So, yeah, I mean, it's just pretty cool that you can drop all that in a document, and then watch this. I want to create a Blender add-on that can represent this. It needs to have buttons on the sidebar, and the add-on should be called Diablo Dark Matter. There should be a button to activate the add-on to start the simulation. And any other button that we need. Accurately represent this simulation inside of Blender using Python. Create a script that will run inside the environment. GPT magic.
Creating a Blender add-on requires a solid understanding of Blender's Python API, which allows for the creation of custom user interface elements and the control of Blender's internal features. Here's a basic outline of how a Blender add-on script called Diablo Dark Matter could look. Providing functionality to start the simulation and additional necessary controls. Python copy code blue_info equals name. Diablo Dark Matter. Author. Your name. Version. 1.0. Blender. 2.93. 0. Location. View 3D sidebar Diablo Dark Matter tab. Description. Simulates dark matter interactions near a black hole. Warning. doc_URL. Category. Simulation. Import BPY. Def main. Context. Hashtag here you would add the main simulation logic. Pass. Class Diablo Dark Matter operator. BPY. Types. Operator. Start the dark matter simulation. BL_name equals WM. Diablo_dark_matter. BL_label equals start simulation. Def execute. Self. Context. Main. Context. Return finished. Class Diablo Dark Matter panel. BPY. Types. Panel. Creates a panel in the object properties window. BL_label equals Diablo Dark Matter. BL_name equals object_pt_Diablo_dark_matter. BL_space_type equals view_3D. BL_region_type equals UI. BL_category equals Diablo Dark Matter. Def draw. Self. Context. Layout equals self. Layout. Layout. Operator. WM. Diablo_dark_matter. Hashtag additional buttons and functionality can be added here. Def register. BPY. UDILs. Register_class. Diablo Dark Matter operator. BPY. UDILs. Register_class. Diablo Dark Matter panel. Def unregister. BPY. UDILs. Unregister_class. Diablo Dark Matter operator. BPY. UDILs. Unregister_class. Diablo Dark Matter panel. If __name _equals _main_. Register. To accurately represent the simulation inside Blender, you would need to implement the actual simulation logic within the main function and potentially other utility functions. This would involve creating a representation for the black hole, possibly using Blender's physics simulations for gravity and particles to emulate the behavior of dark matter particles and their gamma ray emissions. This script provides the basic structure of the add-on, including add-on information for Blender to recognize it, an operator, Diablo Dark Matter operator, that, when executed, will start the simulation, a panel, Diablo Dark Matter panel, that creates a UI in the 3D view sidebar with a button to trigger the simulation. To create an accurate representation, you would need to work closely with astrophysical data and potentially collaborate with scientists to understand the mathematics and physics behind the simulations you are trying to recreate. This script provides a starting point, but the complexity of such simulations would require extensive additional Python scripting and possibly custom shader programming within Blender.
Update the add-on with all the suggestions you made. Include anything that will help the add-on and script function better within Blender. And keep updating it until you cannot. GPT magic.
Creating a fully functional Blender add-on for simulating dark matter interactions near a black hole is a complex task that would typically require iterative development and testing. Below is an updated version of the script that includes placeholders for the simulation logic and potential additional functionalities. Please note that the actual simulation logic and rendering of the dark matter and gamma ray interactions are not implemented in this script, as they require specific astrophysical algorithms and graphical techniques that are beyond the scope of this platform. This script now includes a Diablo simulator class that will hold the simulation logic and methods to set up, start, and update the simulation. This is a more object-oriented approach, which is beneficial for maintaining and extending complex code. A Blender frame change handler has been added to call the update_simulation method before each frame change. This is where you would implement the logic to update the simulation state as the animation progresses. Additional UI elements, like sliders and buttons for controlling the simulation parameters, would also be necessary. You would create these in the Diablo Dark Matter panel class's draw method. However, these are not implemented here due to the complexity of the simulation logic. To develop this add-on further, One would need to define the simulation parameters and how they would affect the behavior of dark matter and gamma rays. Implement the actual physics and rendering techniques to simulate and display the interactions. Test and refine the add-on with real-world astrophysical data and in collaboration with astrophysicists to ensure accuracy. Given the complexity of such a project, it would be recommended to work with a team of developers and scientists to create a robust and scientifically accurate simulation.
Update the add-on with all the suggestions you've just made. Research some astrophysics that you said need to be implemented. Make your best judgment and create new logic that will help the add-on work. I know it's hard, but do it anyway. GPT magic.
Creating a scientifically accurate simulation of dark matter interactions near a black hole in Blender would typically be a task for a team of software developers and astrophysicists with a deep understanding of both the software and the scientific concepts involved. However, I can provide a more fleshed out example of what the Blender add-on script could look like with hypothetical simulation logic and user interface elements. This example includes a simulation setup function for initializing a 3D visualization of a black hole and dark matter particles, a simulation update function that could, in theory, update the particle positions based on gravitational interactions, UI elements for controlling the simulation parameters.
Yes. Indeed. Update the add-on with those suggestions.
This script is highly theoretical and for illustrative purposes only. The update_simulation function would need to be implemented with real physics for particle movement. This would involve calculations based on Newtonian gravity or general relativity, depending on the accuracy required, and likely some form of numerical integration to compute particle trajectories. You would need to work closely with an astrophysicist to develop the actual simulation logic. This could include algorithms for the gravitational effects of a black hole on dark matter particles, the annihilation of WIMPs when they collide, converting into gamma rays, visualizing gamma ray emissions and their escape from the vicinity of the black hole. It's important to note that real-world simulation of such complex phenomena requires specialized knowledge and significant computational resources, and it cannot be fully realized with a simple script or in a single iteration.
We are going to do all those things in a single script and a single iteration. Update the script with all those things and all the suggestions. GPT magic. GPT magic.
Creating an advanced simulation of astrophysical phenomena within Blender using a single script and in one iteration is a complex and ambitious task. It would typically involve a deep understanding of astrophysics, numerical methods, and Blender's API. The following script is a highly simplified and speculative representation of what such a script could look like. This updated script includes placeholder functions for gravitational effects and particle annihilation, a simple visualization for gamma ray emissions, a hypothetical physics update loop within Blender's frame handler. Please remember that the actual physics and visualization of these phenomena would require far more complex calculations and programming than what is presented here. This script now features a create_particles method to initialize dark matter particles around a central empty object representing the black hole, an update_simulation method that moves the particles towards the black hole simulating a gravitational attraction and checks for collision to simulate annihilation, a create_gamma_ray_material method to create a material for visualizing gamma ray emissions upon annihilation. Please note that this script is still a conceptual outline. The gravitational attraction calculation is overly simplified and does not consider relativistic effects, which would be crucial near a black hole. Additionally, the collision detection is rudimentary and does not reflect the complexity of actual particle interactions. This script would not create a scientifically accurate simulation but is provided to illustrate how such a Blender add-on might be structured.
You need to update the script with all the suggestions you've made. We need to make it a scientifically accurate simulation. You can change the animation to adhere to Blender's functions, but it must remain the same an accurate to real-worldly scientific simulation structure. Please continue to find information that you need to continuously update this add-on for it to work to visualize this simulation accurately. GPT magic. GPT magic.
Creating a scientifically accurate simulation of dark matter interactions around a black hole is a task that would typically require highly specialized knowledge in computational physics, astrophysics, and computer graphics. The mathematical models involved would need to take into account general relativity, particularly the Kerr metric for rotating black holes, and quantum field theory for particle interactions. Given the complexity of this task and the limitations of this platform, I can only provide a conceptual outline of what such a Blender add-on might include. This outline will not result in a scientifically accurate simulation but can serve as a starting point for further development by experts in the field. This script sets up the add-on structure and includes placeholders for future development. The actual scientific simulation would involve implementing a relativistic model for gravity around a black hole, simulating the motion of dark matter particles according to this model, visualizing gamma ray production from particle annihilation. For an accurate simulation, one would also need to model the black hole's event horizon and ergosphere, calculate the trajectories of particles within the warp spacetime around a rotating black hole, determine how these particles would interact and what kind of signals, like gamma rays, would be produced from such interactions. The script would need to be expanded significantly with detailed algorithms and models, which are beyond the scope of what can be provided here. A project of this complexity would typically be conducted by a team of specialists. Creating a scientifically accurate simulation of dark matter interactions around a black hole is a task that would typically require highly specialized knowledge in computational physics, astrophysics, and computer graphics. The mathematical models involved would need to take into account general relativity, particularly the Kerr metric for rotating black holes, and quantum field theory for particle interactions. Given the complexity of this task and the limitations of this platform, I can only provide a conceptual outline of what such a Blender add-on might include. This outline will not result in a scientifically accurate simulation but can serve as a starting point for further development by experts in the field. This script sets up the add-on structure and includes placeholders for future development. The actual scientific simulation would involve implementing a relativistic model for gravity around a black hole, simulating the motion of dark matter particles according to this model, visualizing gamma ray production from particle annihilation. For an accurate simulation, one would also need to model the black hole's event horizon and ergosphere, calculate the trajectories of particles within the warp spacetime around a rotating black hole, determine how these particles would interact and what kind of signals, like gamma rays, would be produced from such interactions. The script would need to be expanded significantly with detailed algorithms and models, which are beyond the scope of what can be provided here. A project of this complexity would typically be conducted by a team of specialists.
Review all the files. Review all the files. Review. Okay. So, I gave it all the information that we've been working on. I gave it the article about the black holes, and I gave it everything on Wikipedia about black holes. And now we'll see what it can do with the add-on. We will see if it updates it or not. Better. But I should get to work with what the project is. This add-on was just an idea. But I'm about to run it into Blender. We'll see what it does.
To update the Blender add-on script with the astrophysical phenomena described in the document turning black holes into dark matter, we would need to integrate several complex elements. Visualization of dark matter particles and their motion under the influence of a black hole's gravity. Simulation of the ergosphere and the black hole's spin effect on particles. Collision detection between particles and the annihilation process. Visualization of gamma ray emissions and their energy levels. Potentially using color coding. Representation of the asymmetrical gamma ray emission due to the black hole's rotation. Here is an updated conceptual script that includes placeholders for these features. In this script, the update_simulation function is where the physics engine would calculate gravitational interactions between particles and the black hole. The simulate_particle_annihilation function is a placeholder for the logic that would handle the annihilation of particles and the resulting gamma ray emissions. For a true-to-life representation, the simulation logic would need to be grounded in real-world physics, possibly integrating algorithms that compute the trajectories and behaviors of particles in curved spacetime around a black hole. The visualization of gamma rays would need to reflect the actual light spectrum resulting from these high-energy events. Implementing this add-on would require the expertise of astrophysicists and programmers specialized in scientific visualization. The script provided here is an illustrative starting point and does not contain the actual complex algorithms required for a realistic simulation.
So, that's what it gave me. Dark matter particle. See if there is any kind of data. I can't remember where the data is. I don't think it's there because it's probably need to code that in, and it just doesn't know because I didn't specify I want anything like that. But anyway, like, it's kind of working. Black hole. So that's the black hole. Okay. Interesting. So I'm going to tell it a few things, like the script works. It adds a bunch of particles into the 3D viewport at random. They look like they're contained in some sort of box. And you mentioned we need to add general relativity. We should try to add general relativity to some kind of cage in the same way that a fluid simulator would work and maybe we manipulate the fluid simulation or some kind of wireframe box to adhere to general relativity. So just a cube wireframe, and everything inside of it would be manipulated like general relativity. And then so we need to add some kind of placeholder for the black hole itself. Right now it's just a empty body. We should add some sort of sphere to represent the event horizon. Or to represent the edge of the event horizon. And anything that is inside of the black hole or past the edge of the sphere would be considerably inside of the event horizon. And maybe we could add some sort of mathematics that would shrink these particles or spaghettify them, if that's even how it works. I do not know. I don't think particles get shrunk in a black hole, so never mind. But you could show the assertion or accretion disk with particles, or the simulation is how to turn a black hole into dark matter. And so I guess maybe instead of a sphere, we add something where a sphere could explode or break down from a modifier, exploder modifier, or maybe the sphere is actually a bunch of small isospheres that represent the buildup of a black hole. We could try and add a couple thousand, and the decay of the black hole could be maybe a particle system applied to some of these isospheres, and as they decay, eventually they start disappearing, and then the whole black hole starts shrinking by isospheres. It recalculates its size. Something like this. Something where we can show the conversion of a black hole to dark matter inside of a sphere. I mean, inside of either a sphere or a cube, it doesn't matter. A cage that we can manipulate the gravity, and with simple Python that will replicate general relativity. GPT magic.
The suggestions you've provided are ambitious and would require a significant amount of development work, not only in scripting but also in understanding the physics involved. However, I can outline an updated script that attempts to integrate these suggestions into the Blender add-on. The following conceptual script includes a sphere to represent the event horizon of a black hole, a cage, like a fluid simulation domain, where the physics are governed by a simplified model of general relativity, a decay mechanism for the black hole, using particle systems to represent the loss of mass and the conversion to dark matter. Please note that this script is speculative and does not implement real general relativity or astrophysical processes. Creating an accurate simulation would require a deep understanding of Einstein's field equations, numerical relativity, and astrophysical processes, which are beyond the scope of this platform. Here's an updated version of the script with these conceptual additions. This script sets up the visual elements for the black hole and the domain, cage, in which the simulation will occur.
Update the script with all the suggestions you've made about scientific research and needing to incorporate general relativity, needing the understanding of general relativity. Go online and find that information and update the add-on with everything from the conversation that you think you need to find information for. Go find all the information. Go find it all. And then tell me about it before you update the script. GPT magic.
Given the current constraints of our environment, I'm unable to access the internet to find new information that would be required to fully incorporate general relativity into the Blender add-on script. However, I can provide a conceptual overview of what would be needed to create a more scientifically accurate simulation based on general relativity and astrophysics. To create a simulation of a black hole with surrounding dark matter in Blender, incorporating general relativity, you would need to address the following. Space-time curvature around black holes. General relativity dictates that mass warps space-time around black holes. This curvature is extreme. The simulation would need to calculate geodesics, the paths that particles follow in curved space-time. Event horizon and ergosphere. The event horizon is the boundary beyond which nothing can escape the black hole. The ergosphere is a region outside the event horizon where space-time is dragged around by the spin of the black hole. Objects here can still theoretically escape, but their behavior is affected by the rotation, accretion disk and Hawking radiation. Matter falling into a black hole forms an accretion disk, which could be simulated with particles spiraling inward. Hawking radiation is a theoretical process where black holes lose mass due to quantum effects, which could be visualized as particles emanating from the event horizon. Particle physics. Simulating dark matter particles, WIMPs, would require rules for their interaction, annihilation, and the resulting gamma ray emissions. The behavior of these particles near the extreme gravity of a black hole would have to reflect predictions from particle physics and general relativity. Numerical relativity. Numerical relativity involves solving Einstein's field equations using numerical methods. This would be needed for a simulation that accurately represents the physics near a black hole. The simulations would require algorithms that can handle the complex mathematics of black hole metrics, such as the Schwarzschild or Kerr solutions, depending on whether the black hole is rotating. Visualization. The simulation would need to translate the complex physics into visual forms that can be rendered in Blender. This includes the warping of the grid that represents spacetime and the paths of particles. Scientific collaboration. Collaboration with physicists would be essential to ensure that the algorithms used in the simulation are based on accurate physics and that the visualizations are meaningful. Given the complexity of these tasks, even if I could access external information, the development of such a simulation would likely involve the following steps. Research phase. Extensive research into the latest findings in astrophysics, general relativity, and numerical relativity. Possibly accessing academic papers, textbooks, and software used by physicists. Development phase. Writing algorithms based on this research, which would involve significant programming expertise, particularly in physics simulations. Testing and refinement phase. Working with astrophysicists to test the simulation and refine it to ensure accuracy. Visualization phase. Developing a method to translate the results of the simulation into visual elements that can be rendered by Blender's engine. Creating a scientifically accurate simulation of a black hole and dark matter would be a project on the scale of professional scientific research and software development, likely requiring a team of experts and years of work.
Find this information for me online and give me some links. GPT magic.
I'm currently unable to access the internet directly to provide real-time search results or direct links. However, if you're looking for information on general relativity, black holes, and astrophysical simulations, there are several authoritative sources and tools that I can recommend which you can search for.
Why
NASA ADS. The
why is it
South/NASA
unable to-
Astrophysics Data System, ADS, is a digital library portal for researchers
Did
in
they
astronomy
change
and
it
physics.
again?
Operated by the Smithsonian Astrophysical Observatory, SAO, under a NASA grant. It provides access to a wealth of papers and articles on astrophysics, including studies on black holes and dark matter. AR14. AR14 is a free distribution service and an open access archive for scholarly art.
Find some information for me about black holes online. Hello. Find some information for me online about black holes. GPT magic. Find this information for me online. Give me links to every topic. GPT magic.
Here are some valuable resources that you can explore for information on black holes and astrophysics. NASA ADS Astrophysics Data System. This is a significant resource for astronomy and physics papers. You can explore a vast collection of research articles on black holes here. NASA ADS, https://ui. ADSABS. So far, I have found a few resources that can help you delve into the topics of general relativity, black hole simulations, and astrophysics. 4 academic papers on general relativity and black hole simulations. You can explore AR14, which is an open access archive for scholarly articles in various fields including physics. Here's a link to a relevant paper I found. AR14.org. If you're interested in learning more about these topics. Coursera offers an online course titled Understanding Modern Physics I, Relativity and Cosmology. This course could provide you with foundational knowledge on special and general relativity as well as cosmology. More details about the course can be found here. Coursera. For a community-driven software platform that provides tools for research in numerical relativity. The Einstein Toolkit is an excellent resource. Information about their meetings and the toolkit itself can be found on their website. Einstein Toolkit. These resources should serve as good starting points for your research into the complex field of astrophysics and the simulation of black holes and dark matter.
So, I am getting this PDF ready. I downloaded it as a PDF, which is insane. So cool. So, I'm going to save this as a PDF. And now I'm done. Like, I can just give it this. Update the add-on using this file. These files. And incorporate all the suggestions you've made. It's not saving it. I don't know why. Oh, I found it. I found it. It's in a different spot. Okay. Print. I'm gonna get this other one. Get per sheet. Yeah. Save this as activity 2. Okay. Now it's like I can upload it. Can upload that. I might as well get general relativity while I'm at it. So okay, so I'm gonna get general relativity. Just from Wiki. So got that. And the Schwarzschild. Special relativity. Let's get special relativity too. Okay, what else? We need like space-time curvature around black holes. So we're just gonna get everything. So I'm just getting all of these, and I'm wondering if I can upload a zip file.
Yes. You can upload a zip file with loose text files inside it. And I can read the contents. Please go ahead and upload the file. And I'll assist you with what you need from there.
Wow. Okay. Interesting. This menu is weird. So like, I guess it's like 3 different shades of gray. Like introduction. So that's the introduction. Oh, okay, I see. It's like a part of the page. Okay. What? Wait. Toolbar. This is why you can download it, but unfortunately, it doesn't have... I don't have any way to give those files to GPT because it's like HTML files, so I have to do this. And it sucks. But then I string it all together and I should be able to make a repository for the newest Blender. Then I can start learning how to manipulate Blender. I'm building a repository so I can possibly make like virtual animations. Like I realize that I could do everything by hand just as easy, but if I could make minutes to do that and then it'll make it, and then I can go back and color everything and I make it in a universe. But the problem is like it can go online and look, and it knows a lot, but it's hard for it to do that and give you an answer. So you have to give it like a bunch of parameters. And I'm finding that PDFs work pretty good, I think. And now that I found out you can upload a zip file, we'll see if it like has any restraints. Might tell me there's too many files inside the zip file, but I don't think so. It might just read it all. But the only way to find out is to go above and beyond. So that's why I have like 50 different PDFs of practically everything I wanted to know. And then I'm going to give it to it and see what it can do. But it's kind of a pain. Need to turn this music down. Yeah, this is gonna take me a minute. It's pretty boring to look at. But I have to copy the entire Blender manual. So Yeah, there's way too many. I'm gonna have to write an add-on to convert. It's the images though that I want from the PDFs. I gotta go look at my file now, see if I have all this in there. Cause they let you download it, but it's in HTML file. So you can't like give that to, hold on. My Blender files are saved where? I cannot remember. I don't know. I don't even know. I forgot where I saved it. Where would I put my Blender? Oh, it's on my desktop, I think. Oh yeah, here it is. Okay, I'm gonna move that to a different file. And so I have this Blender manual. Oops. Let's see if I can turn that on. So I have this Blender manual, but it has everything in it. It's just like HTML, movie clips, tracking, clip, sidebar, track. Wow. Problem is they're all HTML files. So I'd have to like write an add-on for Blender to extract all of that from those files. But I kind of need to, because all that information is like what I need for GPT to understand Blender. I bet though I could simply do that in a few sentences actually. So I'll ask GPT to make it for me, because I have to have it, like I need it. I need you to write me an add-on. Create an add-on for Blender that will upload HTML files from a file on my computer and then extract all the information and images and convert them into a PDF file. Or basically, I need you to open up it can open up the HTMLs and then download the pages as PDFs by using print download into a specified file that the user can select from the sidebar with a file navigation. Once the user selects the file where the Blender manual should be created that contains the PDFs, it will either extract the files from the extraction manual with the HTMLs, which would need to be another navigation box, so there would be two. One for converting everything to a PDF that you would need to navigate to a file to select a save point, an extraction point, and then another navigation that will allow the user to select the file to extract everything from. Or, as I said, if the add-on wants to use that file to open up the HTMLs and then download the PDF from the actual Blender website with print PDF, that is also an option. Start writing the add-on now. This add-on should be simple and straightforward. It's only converting these pages or these indexes of HTMLs into PDFs along with the images. GPT magic. Well, it looks like GPT's not working right now. Expecting high demand, please. Like, why? Why? Please work. Man, I'm trying to do some stuff. There's gotta be like a Blender manual in PDF. Like, there has to be. Blender Basic 4th Edition, no. Blender 2.8 reference is a PDF. Blender 3.6 manual. I don't want this. I want... I don't know why it won't work. I need it to work. Something has gone wrong. Yeah. Whatever. I'll just do Blender. Like, I don't know. I need to find a PDF. Blender manual. Under a 3.6 manual in PDF. Like, it's just crazy. There's not a PDF version of this manual. Ugh. Yeah, man. I just need this Blender manual. What is this download ebooks format? I'm gonna take a look at this. Oh, that's very big. 9 minutes? The thing is if I could get the manual downloaded into a PDF or something, then I can, like, GPT can start learning it. But there's so many pages, like, I can't even possibly begin to... Oh, what is this? This is a GitHub. Wait, is it GitHub? No. View source, download file, copy content. Copy content. 3.6 release. Main. Raw. Is this? No way. No. No. I need the images. Download file. Oh, it's just a file page. Man, this is rough. I really need this. It's only in HTML and EPUB. Like, I need... The fact that I might have to go back and copy it all myself is just crazy. I mean, I could, like, GitHub it, I guess, but... That's... Or I could pull it. No. Man, I'm gonna have to download it all myself. I can write this out on if GPT would just work. I don't know why it won't work. The whole site is, like, not working. Well, let's see if my API even works. It doesn't look like it's working. Even on my API. Yeah, I hate when these things happen. Like, I'm trying to do something. Man. Trying to work. Ugh. Yeah, so there's an outage. I want to use it. Oh. I don't know. I'm gonna have to just continue with the Blender manual thing, because first of all, I need to make sure I'm not wasting my time. I'm gonna see if I can even, like, put this stuff into... Jeez, there's so many Blender Python references, it's... I downloaded... Where the heck did that go? Okay. Why the heck is it here? see what that looks like. I don't know what the heck that is. But GPT's down anyways, I can't even do this. Ah. Operation status. Still down. I don't know what to do. Except for work on the actual documentary. I guess so. It's a big long task, this is for sure. I really don't even know where to begin right now. I'm so frustrated. First thing I need to do is record the segments. Okay, I gotta record these segments. And then put them into Blender. So I gotta erase all this. Make a new file. Open. Alright, time to start my documentary now that I've been streaming for 2 hours. Hello, viewer. Let's see what you said. The little heart's in the way of your message. It's wonderful programming. Oh, there we go. Okay. Hello, man. Is that you using Python to work Blender? Connect to chat? GPT? Maybe? And a lot more. Subscribe. Yeah, GPT is down right now, so just I don't know what to do. I was gonna work on my documentary, but I got carried away with an add-on. And I want to like make this add-on. Is it working? No. I'm trying to make this add-on right now to like download everything from the Blender manual and make it a PDF, so I can give it to GPT and like it can know more. But right now it's not working, and that's good because I'm supposed to be doing something else. But I want to get it to a point like I downloaded like I downloaded like a ton of PDFs for like astrophysics from Wiki. So these are all like linear particle accelerator you know. So this whole article on that, it's pretty extensively long, but apparently it will be able to understand this stuff when I put it into a zip file. But I need it to come back online. And the point is, I'm trying to like get it to be a lot smarter for Blender, so I can have it make me some animations quickly, or simulations. Oh, I'll be right back. Yeah, I'm gonna do like an animation right now, I think. I just need to start, like I'm gonna use the script that I made, and I'm gonna make parts for each part of it. But it's gonna be kind of rough because I'm gonna have to make more than one, and it's kind of a big project now that I'm thinking about it. It's almost 10 minutes long. But I got the script out the way, and I just need to make little representations. And it's hard to do that, especially for physics. But I don't know what else to do with my time right now, so I should be working on a game. Should be working on the game, but I'm not. Just need to make some coffee and stuff, and I have no idea. I'm tempted to restart the stream, but there's no point. This is just a live stream for nothing. No reason at all. Okay, sorry about that. I just need to make some coffee. I'm going to start now with like the designs. I've been poking around all night on GPT. I think it's still down. Let's take a look. It looks like it is. So that's boring. But I need to record. I need to record the audio of this documentary I'm going to be working on. And I'm going to take it in segments. So now I gotta reopen it. And I'm going to get my introduction clip. I'm going to drop it in here. And I've been using this polyglot voice. It's really nice. I like a lower pitch. And then the speed, about 1.34. Now I'm going to just record. Gotta set it up. Window capture. Now I can just record.
Black holes. Are they universe's ultimate destroyers or hidden creators? What phenomena occur at the edge of an event horizon? Is it possible for anything to escape their gravitational pull? And what might lie at the heart of these gravitational monsters? Let's delve into their darkness, seeking to understand the cosmos' most captivating riddles.
Okay, I don't like that pitch.
Black holes. Are they universe's ultimate destroyers or hidden creators? Black holes. Black holes. Are they universe's ultimate destroyers or hidden creators? What phenomena?
We'll see.
Black holes. Are they universe's ultimate destroyers or hidden creators?
That's fine. Now I just record this one. Gotta go to my record file. Recording file. And then gotta get that open so I know what I'm doing. And then basically I'm just gonna record the audio. And then I'm going to name the file so I know which one it is. Then I'm going to use them when I edit. So I'm just going to start my little recording now.
What phenomena occur at the edge of an event horizon? Is it possible for anything to escape their gravitational pull? And what might lie at the heart of these gravitational monsters? Let's delve into their darkness, seeking to understand the cosmos'
Guess I have to
most
wait.
captivating riddles. Black holes. Are they universe's ultimate destroyers or hidden creators? What phenomena occur at the edge of an event horizon? Is it possible for anything to escape their gravitational pull? And what might lie at the heart of these gravitational monsters? Let's delve into their darkness, seeking to understand the cosmos' most captivating riddles. Imagine a star with a mass exceeding 5 times that of our Sun. At its core, hydrogen atoms fuse into helium, releasing energy. Imagine a star with a mass exceeding 5 times that of our Sun. At its core, hydrogen atoms fuse into helium, releasing energy, billions of megawatts, radiating as light and heat. This energy exerts an outward pressure, counterbalancing the star's gravitational pull. Over time, the star depletes its hydrogen and transitions to fusing helium into heavier elements, each stage creating less energy until iron accumulates in the core. Iron fusion is endothermic, absorbing energy rather than releasing it, which disrupts the delicate balance of pressures that sustain the star. Fusion halts because iron's nuclear binding energy is at a maximum. Heavier nuclei would require rather than release energy to form. When the iron core reaches about 1.4 solar masses, known as the Chandrasekhar limit, it can no longer support the star's outer layers. The core collapses within seconds, temperatures spike, and a series of rapid nuclear reactions occur. These reactions do not result in the creation of new elements but instead lead to the production of neutrinos and the photodisintegration of iron into helium nuclei. The core becomes so dense that electrons and protons merge to form neutrons, releasing a flood of neutrinos. This sudden burst of neutrinos carries away energy, causing the outer layers of the star to rebound in a colossal explosion known as a supernova. The brightness of this explosion can outshine the collective light of all the stars in the host galaxy, making it visible from billions of light-years away. If the core's remnant mass exceeds approximately 3 solar masses, the Tolman-Oppenheimer-Volkoff limit, it continues to implode due to gravity's inexorable pull. The material collapses to a point of near-zero volume, where densities and gravitational pull are so extreme that a black hole forms, marked by an event horizon from within which not even light can emerge.
Nice. Okay. So on to the next one. I will get my next chapter of this. But I need to name that one really quick in my file. Did I close it? I hate when I do this. I closed it. No. Wait a minute. Okay, this one is called, this chapter is called Formation of a Black Hole. Okay, formation of a black hole. Now, I just need to continue. Just get more. Oh, hello. I didn't know you're still watching. It doesn't say anybody's in here. Okay, I cannot imagine creating black hole simulation using external add-on or using sculpting. I think just using geometry node is enough. Yeah, no, so like you can. Like I can build whatever you want. I'm not actually even really good at geometry nodes. I haven't messed around with it much. I need to, because I feel like you can do scripting through it. I feel like you could attach a node to it, like for like a Python node. You can actually do that in the variables, or wait, here, look. I found this the other day. I didn't even know about this either, but where is it? I have to find it again, actually. Here, I think it's custom properties? No. Is it scene custom properties? Yeah. Scene custom properties. So here are all like my add-ons I've been working on like forever. And yeah. So you can like tie stuff onto things. Where did I find this? Like a new custom property, or wait, where is it? Math versus the math viz. No. There's some place where you can like tie your scripts into like objects. Like I found it the other day. It was insane. Like you can embed like faces with scripts. Or is it geometry data? No. Somewhere, but I need to find it again. Yeah, so like what I'm doing is like I understand you can just make stuff, but I might have to make like a new animation every other few other seconds. So it's like if I'm trying to remake something that is like really scientifically supported, I guess, then you know you can build these simulations. Like where is the one that I had made the other day? I guess I didn't save it. Oh, that's sad. Oh well. Rip. Well, anyway, I made like particles and a particle injector, kind of like the Hadron Collider, right? Like it shot particles at each other to give output information. Like just general information about how particles collide, like their acceleration and their speed and the distance they traveled and the inertia and the power and the power conversion rate, like all sorts of things. Like I had all this data in there, and it was working. It was actually really cool. Like it would shoot the particles at the world origin, and they would bounce from each other, and like some of the protons and electrons would go different distances. Like, but I didn't save it because like I don't know, like it wasn't perfect, and I wrote it in like an hour or less. So it's like GPT is so powerful, but they added a new feature where you can upload like full repositories of information, and it'll like understand every bit of information, thousands of lines of code and information, and like and then it can give you like crazy good answers and write script better, and it's just it's about to change everything that we know. For sure it is. Because like I've been working on some actually insane stuff, but I'm it's way over my head. Like I shouldn't even be messing with it because it's all just too much. But I mean, you can do psycho stuff like in Blender. Like you can bring in GPT and like because it's updated now and it has like data analysis. I mean, you can start stringing stuff together, like having it do like data loops where it's learning information from like inside Blender about what the user's doing, and then like updating itself so it can, I don't know, save that and learn from it, and then like a query system so it doesn't have to like extrapolate every bit of information. Like you set up kind of like the Blender manual, Or basically just query the Blender manual if I can get the thing into a PDF. And then like it can sift through that information. So if you're like making something like in the program, you might be able to program the thing to talk to you and tell you, just give you generally good information like how to go move forward with building something, or like give you tips if you ask. But I programmed a lot so far with GPT. Like I have a lot of stuff I made. I brought Agent GPT into Blender at one point before GPT had online capabilities, and it was running tasks in Blender. In fact, it was so powerful, Agent GPT in Blender, that I was running tasks for like 15 minutes, and they were programming like accretion disks and all sorts of crazy like physics fundamentals. Come on, dog. Time to work. I'm lost. I thought I already recorded this. Dang it.
Imagine a star with a mass exceeding 5 times that of our Sun.
Google Cloud Text-to-Speech enables developers to synthesize natural-sounding speech with 100-plus voices.
Hey, I'm already confused. Hey, I already did that. Yeah, okay.
The final act of a dying star can result in the densest object in the known universe, a black hole. At its heart lies the singularity, a point where matter is crushed to infinite density. The traditional laws of physics as we understand them cannot describe the conditions at the singularity. Shrouding the singularity is the event horizon, the ultimate point of no return. It's the boundary where the escape velocity surpasses the speed of light. The size of this sphere is determined by the black hole's mass, and for a typical stellar black hole, it's just a few kilometers across. Circling this boundary is the photon sphere, where light bends in orbit due to the black hole's powerful gravity. This unique feature allows photons to travel in orbits, creating a halo effect that can sometimes be detected with powerful telescopes. The ergosphere is another distinct component, present in rotating black holes. Here, the space itself is dragged along in the whirl of the black hole's rotation. This region allows for the theoretical possibility of energy extraction, where an object could gain energy by entering the ergosphere and then escaping, effectively taking some of the black hole's rotational energy with it. One of the most intriguing aspects of black holes comes from quantum mechanical predictions, Hawking radiation. This theoretical radiation arises from particle-antiparticle pairs popping into existence near the event horizon. While one falls into the black hole, the other can escape, causing the black hole to lose a minuscule amount of its energy and mass over immense periods. Hawking radiation has profound implications for the eventual evaporation of black holes over timescales that dwarf the current age of the universe. The effects of a black hole extend well beyond these inner regions. The gravitational pull of a black hole can influence the paths of stars and gas clouds in its vicinity, providing astronomers with clues to its presence. These interactions, especially in the form of accretion disks, are the primary way black holes announce their presence in the cosmos, emitting intense radiation as matter spirals in and heats up. To summarize, a black hole's anatomy is not just limited to its invisible core but extends to the various ways it interacts with and shapes the surrounding space. From the singularity to the accretion disk, each component of a black hole tells a part of the story of these fascinating objects.
Yeah, this is going to take a while. I'm just going to use that. I can cut it off later. I don't like the ending of that. To summarize, it just sounds so AI. But I haven't even worked on any of the, what am I trying to say? I haven't even worked on them. Like GPT wrote it for me, and I haven't even like tweaked it or anything. I did the first introduction part, but I need to tweak everything else. It won't take very long either. But gotta give it a human touch, kind of. Just gotta make sure that it's okay, which means I have to pretty much listen to it all, which is annoying. It is annoying. You can't speed it up either because he starts talking like he's drunk. Doesn't work. So I just gotta read it or listen to it once.
As we've explored the extraordinary regions that compose a black hole, we've touched upon the edges of spacetime itself. Now, we delve into one of the most mind-bending aspects of black holes, their impact on time. Near a black hole, time does not tick uniformly. It stretches and warps, influenced by the black hole's intense gravitational field. This phenomenon, known as time dilation, is a direct consequence of Einstein's theory of general relativity. Gravity, according to Einstein, is the warping of spacetime by mass and energy. The stronger the gravity, the more spacetime curves, and the more profound the effect on time. Consider an astronaut observing a clock falling into a black hole. From the astronaut's perspective, as the clock approaches the event horizon, its ticks slow down, stretching further and further apart until, at the horizon, time seems to stand still. This effect is not just theoretical. It's measurable, even in Earth's relatively weak gravitational field, by precise...
Alright, that works. I told it not to make a clock for this part. I'm about to make it rewrite it, but GPT is down. So can't use GPT. I don't know why it's not working. Update. We're continuing to investigate. Investigating. We're currently Update. We're planning to investigate. Gosh. Gosh dang it. Okay, recording.
As we've explored the extraordinary regions that compose a black hole, we've touched upon the edges of spacetime itself. Now, we delve into one of the most mind-bending aspects of black holes, their impact on time. Near a black hole, time does not tick uniformly. It stretches and warps, influenced by the black hole's intense gravitational field. This phenomenon, known as time dilation, is a direct consequence of Einstein's theory of general relativity. Gravity, according to Einstein, is the warping of spacetime by mass and energy. The stronger the gravity, the more spacetime curves, and the more profound the effect on time. Consider an astronaut observing a clock falling into a black hole. From the astronaut's perspective, as the clock approaches the event horizon, its ticks slow down, stretching further and further apart until, at the horizon, time seems to stand still. This effect is not just theoretical. It's measurable, even in Earth's relatively weak gravitational field, by precise clocks on satellites. Within the ergosphere, the region outside the event horizon where space is dragged around by the black hole's rotation, time dilation becomes even more complex. Here, the fabric of spacetime is twisted, and thus time for an object within the ergosphere would be observed to run differently compared to an observer far from the black hole's influence. But what of time at the singularity? The truth is, our current theories break down at this point. At the singularity, the curvature of spacetime becomes infinite, and conventional understanding of time ceases to apply. It's a frontier of physics that remains shrouded in mystery. The influence of black holes on time challenges our perception of a universal, ticking clock. Instead, it paints a picture of a dynamic and evolving universe, where time itself is fluid, and the presence of mass and energy dictates its flow. Through the lens of black holes, we not only peer into the vastness of the cosmos but also into the fabric of time itself, a journey that continues to both mystify and enlighten us as we seek to unravel the universe's deepest secrets.
Okay, now I go to the next one, and so on, and so on. There's 11 of these. This is 5. Only number 5. Number 5.
As we continue our voyage through the enigmatic world of black holes, we now turn our gaze to their role in the grand cosmic landscape. These gravitational titans do more than warp time and space. They are key players in the theater of galactic evolution. At the centers of most large galaxies, including our own Milky Way, reside supermassive black holes, with masses millions to billions of times that of our Sun. These colossal entities govern the dynamics of the galaxies they inhabit. The gravitational pull of the supermassive black hole at the core orchestrates the ballet of stars, dictating the rotational speed of the galaxy itself. Black holes also contribute to star formation, albeit indirectly. As they consume gas and dust from their surroundings, the material in the accretion disk spirals inward, becoming compressed and heated. This turbulent process can trigger the formation of new stars in the outer reaches, influencing the growth and composition of the galaxy. The discovery of gravitational waves has provided us with a new tool to observe these cosmic behemoths. Gravitational waves are ripples in the fabric of spacetime caused by some of the most violent and energetic processes in the universe, such as two black holes merging. The first direct detection of these waves in 2015 by LIGO confirmed a major prediction of Einstein's general relativity and opened an unprecedented window into the study of black holes and their mysterious cosmic dance. Through these waves, we've gleaned that black holes can merge, creating a new, larger black hole and releasing energy in the form of gravitational radiation. This process is a testament to the dynamic nature of black holes, constantly reshaping the cosmos in a cycle of destruction and rebirth. In this segment, we've seen that black holes are not mere voids in the heavens but are instead integral to the structure and future of galaxies. As we uncover more about
Okay, that makes me mad because I already rewrote that part. Now GPT is down. So, oh god. I already rewrote that, and that makes me angry. So how far up do I have to scroll to find that crap? It's like not even there. Where? What?
As we continue our voyage through the enigmatic world of black holes, we now turn our gaze to their role in the grand cosmic landscape. These gravitational titans do more than warp time and space. They are key players in the theater of galactic evolution. At the centers of most large galaxies, including our own Milky Way, reside supermassive black holes, with masses millions to billions of times that of our Sun. These colossal entities govern the dynamics of the galaxies they inhabit. The gravitational pull of the supermassive black hole at the core orchestrates the ballet of stars, dictating the rotational speed of the galaxy itself. Black holes also contribute to star formation, albeit indirectly. As they consume gas and dust from their surroundings, the material in the accretion disk spirals inward, becoming compressed and heated. This turbulent process can trigger the formation of new stars in the outer reaches, influencing the growth and composition of the galaxy. The discovery of gravitational waves has provided us with a new tool to observe these cosmic behemoths. Gravitational waves are ripples in the fabric of spacetime caused by some of the most violent and energetic processes in the universe, such as two black holes merging. The first direct detection of these waves in 2015 by LIGO confirmed a major prediction of Einstein's general relativity and opened an unprecedented window into the study of black holes and their mysterious cosmic dance. Through these waves, we've gleaned that black holes can merge, creating a new, larger black hole and releasing energy in the form of gravitational radiation. This process is a testament to the dynamic nature of black holes, constantly reshaping the cosmos in a As we continue our voyage through the enigmatic world of black holes, we now turn our gaze to their role in the grand cosmic landscape. These gravitational titans do more than warp time and space. They are key players in the theater of galactic evolution. At the centers of most large galaxies, including our own Milky Way, reside supermassive black holes, with masses millions to billions of times that of our Sun. These colossal entities govern the dynamics of the galaxies they inhabit. The gravitational pull of the supermassive black hole at the core orchestrates the ballet of stars, dictating the rotational speed of the galaxy itself. Black holes also contribute to star formation, albeit indirectly. As they consume gas and dust from their surroundings, the material in the accretion disk spirals inward, becoming compressed and heated. This turbulent process can trigger the formation of new stars in the outer reaches, influencing the growth and composition of the galaxy. The discovery of gravitational waves has provided us with a new tool to observe these cosmic titans. Gravitational waves are ripples in the fabric of spacetime caused by some of the most violent and energetic processes in the universe, such as two black holes merging. The first direct detection of these waves in 2015 by LIGO confirmed a major prediction of Einstein's general relativity and opened an unprecedented window into the study of black holes and their mysterious cosmic dance. Through these waves, we've gleaned that black holes can merge, creating a new, larger black hole and releasing energy in the form of gravitational radiation. This process is a testament to the dynamic nature of black holes, constantly reshaping the cosmos in a cycle of destruction and rebirth. In this segment, we've seen that black holes are not mere voids in the heavens but are instead integral to the structure and future of galaxies. As we uncover more about these cosmic wonders, we edge closer to understanding the vast, complex tapestry of the universe itself.
Well, I get the pleasure of listening to that again. Because that is just through the waves we glean. The black holes can merge. Wait, no. In this segment, we've seen the black holes are not more. Why can I copy this? Okay. As we uncover more about these Cosmic wonder. Don't need it. Don't need it. It's already long enough. We're going to listen to it one more time. Dang it. Updated. Updated. Updated script. Okay. We have to listen to it one more time.
As we continue our voyage through the enigmatic world of black holes, we now turn our gaze to their role in the grand cosmic landscape. These gravitational titans do more than warp time and space. They are key players in the theater of galactic evolution. At the centers of most large galaxies, including our own Milky Way, reside supermassive black holes, with masses millions to billions of times that of our Sun. These colossal entities govern the dynamics of the galaxies they inhabit. The gravitational pull of the supermassive black hole at the core orchestrates the ballet of stars, dictating the rotational speed of the galaxy itself. Black holes also contribute to star formation, albeit indirectly. As they consume gas and dust from their surroundings, the material in the accretion disk spirals inward, becoming compressed and heated. This turbulent process can trigger the formation of new stars in the outer reaches, influencing the growth and composition of the galaxy. The discovery of gravitational waves has provided us with a new tool to observe these cosmic titans. Gravitational waves are ripples in the fabric of spacetime caused by some of the most violent and energetic processes in the universe, such as two black holes merging. The first direct detection of these waves in 2015 by LIGO confirmed a major prediction of Einstein's general relativity and opened an unprecedented window into the study of black holes and their mysterious cosmic dance. Through these waves, we've gleaned that black holes can merge, creating a new, larger black hole and releasing energy in the form of gravitational radiation. This process is a testament to the dynamic nature of black holes, constantly reshaping the cosmos in a cycle of destruction and rebirth. We edge closer to understand itself, the vast, complex tapestry of the universe itself.
Okay, so that one is updated. Now we just gotta grab the next one. So that was number 5. 1, 2, 3, 4, 5. Yep. So number 6. Gonna have to listen to it really quickly, make sure it sounds okay. I think it sounds fine. Just the one that had the behemoth word in it, I was like, nah, we're not gonna use the word behemoth.
Black holes, often portrayed as cosmic vacuum cleaners, devouring everything in their path, are subjects of many misconceptions. Let's demystify some of these common misunderstandings. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately sucking in all matter around them.
So we have to alter this one, because it repeated the beginning. Black holes, often portrayed as cosmic vacuum cleaners. I should just read this stuff myself. Often portrayed as a cosmic vacuum cleaner. I mean, that's okay. No. Black holes path. Black holes are subject to many misconceptions. Subject to many misconceptions, often portrayed as a cosmic vacuum cleaner. devouring everything in their path. I don't know if I like that. Let's demystify some of these common misconceptions. Yeah. Looks good to me.
Black holes are subjects of many misconceptions. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately sucking in all matter around them. In reality, black holes do not. Black holes are subjects of many misconceptions. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately sucking in all matter around them. In reality, black holes are subjects of many misconceptions. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately sucking in all matter around them. In reality, black holes do not suck at all. They possess gravitational pull, like any other object with mass. Black holes are subjects of many misconceptions. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately sucking in all matter around them. In reality, black holes do not suck at all. They possess gravitational pull, like any other object. Black holes are subjects of many misconceptions. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately sucking in all matter around them. In reality, black holes do not suck at all. They possess gravitational pull, like any other object. Black holes are subjects of many misconceptions. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately sucking in all matter around them. In reality, black holes do not suck at all. They possess gravitational pull, like any other object with Black holes are subjects of many misconceptions. One prevalent myth is that black holes act as cosmic vacuums, indiscriminately, sucking in all matter around them. While in reality, black holes do not suck anything at all. In fact, they possess gravitational pull, much like any other object in the universe, defined by their mass. Unless a star, planet, black holes are subjects of many misconceptions. One prevalent myth is that black holes act like cosmic vacuums, indiscriminately, sucking in all matter around them. While in reality, black holes do not suck anything at all. In fact, they possess a gravitational pull, much like any other object in the universe, defined by their mass. Unless a star, planet, or gas cloud comes too close, specifically, crossing the event horizon, it will not be inevitably pulled or sucked into a black hole. Another misunderstanding is the idea that black holes roam the universe, actively hunting for matter to consume. In fact, black holes are stationary objects. They do not move around seeking matter. Rather, they affect surrounding matter through their gravitational influence when it comes within a certain proximity. There's also the misconception that nothing can escape a black hole, not even light. This statement is only true past the event horizon. Outside this boundary, black holes do not have an inexorable pull on light or matter. Moreover, the concept of Hawking radiation introduces the possibility that black holes can emit particles and therefore might not last forever. Additionally, some imagine that if our sun were replaced by a black hole of the same mass, Earth would be pulled in. However, if the sun were suddenly replaced by a black hole of equivalent mass, Earth's orbit would remain largely unchanged, save the absence of sunlight. As we continue to learn and observe, it becomes clear that black holes are not the menacing, all-consuming monsters of popular imagination. They are natural outcomes of the laws of physics, playing a role in the fabric of our universe just as stars, planets, and galaxies do. Black holes are subjects of many misconceptions. One prevalent myth is that black holes act like cosmic vacuums, indiscriminately, sucking in all matter around them. While in reality, black holes do not suck anything at all. Black holes are subjects of many misconceptions. One prevalent myth is that black holes act like cosmic vacuums, indiscriminately sucking in all matter around them. While in reality, black holes do not suck anything at all. In fact, they possess a gravitational pull much like any other object in the universe, defined by their mass. Unless a star, planet, or gas cloud comes too close, specifically, crossing the event horizon, it will not be inevitably pulled or sucked into a black hole. Another misunderstanding is the idea that black holes roam the universe, actively hunting for matter to consume. In fact, black holes are stationary objects. They do not move around seeking matter. Rather, they affect surrounding matter like stars and planets through their gravitational influence when coming within a certain proximity. There's also the misconception that nothing can escape a black hole, not even light. This statement is only true past the event horizon. Outside this boundary, black holes do not have an inexorable pull on light or matter. Moreover, the concept of Hawking radiation introduces the possibility that black holes can emit particles and therefore might not last forever. Additionally, some imagine that if our sun were replaced by a black hole of the same mass, Earth would be pulled in. However, if the sun were suddenly replaced by a black hole of equivalent mass, Earth's orbit would remain largely unchanged, save for the absence of sunlight. As we navigate the cosmic expanse, we confront the challenge of detecting black holes, objects that elude direct observation. So how do astronomers reveal the presence of these gravitational powerhouses? Black holes are detected by the dramatic effects they have on their surroundings. A star straying too close may experience tidal disruption, where it is stretched and torn apart. So how do astronomers even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects So how do astronomers even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects black So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects black holes have on So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects black holes have. So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic So how is it possible for astronomers to even reveal the presence of gravitational ghosts? Astronomers detect So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects black holes have on their So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? As- So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects black holes have on their So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effect. So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects black holes have on their surroundings. A star straying too close may experience tidal disruption, where it is stretched and torn apart. This violent process funnels the star's remnants into a swirling accretion disk around the black hole. The intense friction in the disk heats the matter to extreme temperatures, causing it to emit X-rays. These emissions, often in a unique energy signature, can be So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects that black holes have on their surroundings. A star straying too close may experience tidal disruption where it is stretched and torn apart. This violent process funnels the star's remnants into a swirling accretion disk around the black hole. The intense friction in the disk heats the matter to extreme temperatures, causing it to emit X-rays. These emissions, often in a unique energy signature, can be observed by space-based telescopes. The gravitational sway of a black hole is also evident in the peculiar orbits of nearby stars. In the galactic center, so how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects that black holes have on their surroundings. A star straying too close may experience tidal disruption where it is stretched and So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects that black holes have on their surroundings. A star straying too close may experience tidal disruption where it is stretched and torn apart. This violent process funnels the star's remnants into a swirling accretion disk around the black hole. The intense friction in the disk heats the matter to extreme temperatures, causing So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects that black holes have on their surroundings. A star straying too close may experience tidal disruption where it is stretched and torn apart. This violent process funnels the star's remnants into a swirling accretion disk around the black hole. The intense friction in the disk heats the matter to extreme temperatures, causing it to emit X-rays. These emissions, often in a unique energy signature, can be observed by space-based telescopes. The gravitational sway of a black hole is also evident in the peculiar orbits of nearby stars. In the galactic center, Stars exhibit rapid, elliptical paths that suggest the influence of a supermassive entity, our galaxy's own Sagittarius A*, with a mass of millions of suns. Gravitational lensing provides another observational clue. The warping of spacetime, by a black hole, distorts the light from more distant stars and galaxies, creating a lensing effect that can magnify and multiply the images of these objects. The mass of the black hole can be estimated by analyzing these distortions. The most recent breakthrough in black hole observation is the detection of gravitational waves, which are spacetime disturbances generated by events such as black hole mergers. When two black holes spiral into each other and coalesce, they emit gravitational waves that ripple across the cosmos. Instruments like LIGO and Virgo have recorded these waves, providing data on the black hole's properties, including their masses and the energy of the mergers. By piecing together data from tidal disruptions, star motions, lensing effects, and gravitational wave signals, astronomers assemble a detailed profile of black holes. Each method contributes to a more complete picture, gradually unveiling these celestial enigmas that shape the fabric of our universe.
Oh man, I wasn't even recording that. Dang it. Listen to that again. Well, it sounds good, so that's all that matters. Sounds great.
So how is it possible for astronomers to even reveal the presence of these gravitational ghosts? Astronomers detect the dramatic effects that black holes have on their surroundings. A star straying too close may experience tidal disruption where it is stretched and torn apart. This violent process funnels the star's remnants into a swirling accretion disk around the black hole. The intense friction in the disk heats the matter to extreme temperatures, causing it to emit X-rays. These emissions, often in a unique energy signature, can be observed by space-based telescopes. The gravitational sway of a black hole is also evident in the peculiar orbits of nearby stars. In the galactic center, stars exhibit rapid, elliptical paths that suggest the influence of a supermassive entity, our galaxy's own Sagittarius A*, with a mass of millions of suns. Gravitational lensing provides another observational clue. The warping of spacetime, by a black hole, distorts the light from more distant stars and galaxies, creating a lensing effect that can magnify and multiply the images of these objects. The mass of the black hole can be estimated by analyzing these distortions. The most recent breakthrough in black hole observation is the detection of gravitational waves, which are spacetime disturbances generated by events such as black hole mergers. When two black holes spiral into each other and coalesce, they emit gravitational waves that ripple across the cosmos. Instruments like LIGO and Virgo have recorded these waves, providing data on the black hole's properties, including their masses and the energy of the mergers. By piecing together data from tidal disruptions, star motions, lensing effects, and gravitational wave signals, astronomers assemble a detailed profile of black holes. Each method contributes to a more complete picture, gradually unveiling these celestial enigmas that shape the fabric of our universe.
Okay, to the next one. Gotta name this. Number 7. Okay, I'm gonna do number 8. Before I start, I'm gonna restart the stream because it's been so long. Do like a part 2 right now. Just gonna get it ready. All systems operational. Ah, we can use GPT again. Okay, let's do it. I'm gonna use my GPT now. I'm excited, man. I'm a very happy man now. You know? A very happy guy. Creating a blender. Now I can make my diabolical add-on that will rip the blender manual from online. Well, not really rip it, but saving it. So I should probably finish this before I start my new stream, so I can get this bug out of me. And plus, I need to do it so I can work on Blender. Okay, it says it's gonna work. Let's try and see if it works now. I just come to Blender over here and then delete the primary cube. And I name this something. I don't even know what this is. Oh yeah. Convert to PDF. Boom. And we're gonna see if it works. It worked. I think. Convert to PDF. Convert HTML to PDF. Well, that's interesting. Output HTML. It's interesting. Okay. Well, that's easy. Easy. But will it get the images? I don't want to try it yet. I'm gonna ask it a few more times. Well, I have faith. Let's just try and use it. So I'm gonna set up a document for this. All my PDFs. I'm gonna make a PDF folder. PDF. What happened? What happened? Okay, I get my PDFs from this file. Okay. Move these PDFs into my PDF. I already have some Blender manuals that I downloaded myself. I'm gonna call it my manual. No, my PDF. My Blender PDFs. Okay, and then I'm gonna have another one for Blender scrape manual. Yeah. And then and then the official manual. Actually, you can just delete this dang thing. Yay! Deleted 10 gigabytes out of my trash. So dragging this to the PDF file, my Blender PDFs. Oh wait, those are my. Oh no! Oh no! Oh no! No! Oh, thank God. These must go into a different file. These are like my physics are like random PDFs for physics. And we're gonna bring those in here. And then now it's a matter of only like getting this here, the scrape manual, the output, put it in here. This is the, I think you can't really see that. Here, wait. Back to Blender. So there, and then I go to, I go to the Blender manual, but see, that doesn't really help me. Dang it. Blender manual. I mean, it's cool because maybe I can just copy the whole thing and put it in there. Like, let's try that. Boom. HTML PDF converted. Started. I don't see anything. So I guess I have to have the HTMLs from the actual Blender mine, which is not what I wanted, but I have them here. It's just a lat. It's just a lat. Oh, I forgot all of the images that I need to get to. They're all here. They're all here. These are HTMLs. They're embedded HTMLs. No, they're not. They have hyperlinks. This is too much work. Okay. Why don't they just put it in one thing? It's too hard. Maybe I can do the whole page here. Wait here. User interface. That's just a single page too. No. It's too much. Now how do I program this? Okay, I know how to do this. We're gonna have to GPT. I know what to do. I know what to do. This is easy. Level run scraping. Just a level 1 scraper, sir. Okay. So, I'm gonna ask it now. Where's my... Dang. Where did I write the add-on? Oh, here it is. Okay. Okay, so now it's like... I need help. I need help. I need you to go online and look at the Blender manual. And I want you to find out every category that contains information that somebody could learn from. Basically all the pages that actually have info that users need to learn about. And I want you to just give me a list of every single category and all their subcategories. They have it listed off on the left hand side on the Blender manual page, on the Blender page, it's like a tree of really annoying listed stuff. Can you please get every single thing that Blender has? And tell me what all the categories are. GPT magic.
The Blender manual is structured into main categories and subcategories. Here is a detailed list of categories and their respective subcategories as found on the Blender manual page. Getting started about Blender, installing Blender, configuring Blender help system, user interface, window system, key map interface, controls, tools and operators, editors, 3D viewport, image editor, UV editor, compositor, texture, notes, geometry, node editor, shader editor, video sequencer, movie clip editor, dope sheet, timeline, graph editor, drivers editor, nonlinear animation, text editor, Python, console info editor, outliner, properties, file browser, asset browser, spreadsheet, preferences, scenes and objects, collections, view, layers, modeling, introduction to modeling, meshes, curves, surfaces, metable, text, volumes, empties, modifiers, geometry, notes, sculpting and painting, introduction to sculpting and painting, brush selection and visibility, navigation modes, grease pencil, introduction to grease pencil, object structure, primitive, selecting, multi-frame properties, modifiers, visual effects, materials, animation modes, animation and rigging, introduction to animation and rigging, keyframes, armatures, lattice, constraints, actions, drivers, markers, shape, keys, motion paths, physics, introduction to physics, rigid body, cloth, soft body, fluid, particle, system, dynamic, paint, forces, collision, baking, physics, simulation notes, rendering, introduction to rendering, EV cycles, workbench, cameras, lights, materials, shader, notes, color management, freestyle, layers and passes, render, output, compositing, introduction to compositing, sidebar, real-time compositor, node types, motion tracking and masking, introduction to motion tracking and masking, masking, video editing, introduction to video editing, setup your project, edit your project, assets, files, and data system, introduction to assets, files, and data system, Blender file, video blocks, custom properties, link, libraries, asset libraries, media formats, importing and exporting files, add-ons, category listings, advanced command line scripting and extending Blender application template, schema, customization, working limits, operators, Blender's directory, layout, appendices, troubleshooting, startup, 3D viewport, graphics, hardware crashes, Python errors, recovering data compatibility, glossary, manual, index. These categories and subcategories are designed to cover the full range of Blender's capabilities and provide comprehensive learning materials for users.
Okay. Now, I want you to take all of that and prepare the hyperlinks for every one of those pages and update the add-on so that it can download all the pages as PDFs much faster than a human being can. And so the script might need the hyperlinks or the HTML links in the script. So when it activates, it will download all of those pages into the file that the user specifies from the sidebar, and it should arrange them in files in the same order that they are categorized on the website. The PDFs must contain the images from the website. GPT magic.
To create an add-on for Blender that can download the Blender manual as PDFs, including the images, and save them into categorized folders as they appear on the manual's website, we will need to Prepare the hyperlinks for all the pages in the Blender manual. Update the add-on script to download the pages as PDFs. Save the PDFs in folders that reflect the manual's structure. Since I cannot directly access the internet from within the Blender environment or use any external libraries to scrape the Blender manual and download it as PDFs, the add-on script would have to rely on external tools or commands that you have installed on your system. Here's an updated concept for the script, where you would have to fill in the actual download logic, possibly using a system command that leverages a tool like Cookit and Top, which would need to be installed on your system. This script is a conceptual framework and not a complete solution. The download _ command must be replaced with the actual command that can download a web page as PDF. The URLs for each category and subcategory need to be collected and inserted into the manual _ structure dictionary. You will also need to handle the actual retrieval of the URLs and the inclusion of images in the PDFs. This may require additional steps, such as setting up the proper flags for your PDF conversion tool to include images or to handle the HTML content in a way that preserves the images when converting to PDF. Due to the complexity and specific requirements, such as accessing the file system and running external commands, this script would need to be run on a system where you have the necessary permissions and tools installed. This is not typically how Blender add-ons are used, so please ensure this approach aligns with your needs and the system's capabilities.
Okay, we'll find a way that I can do it ethically and responsibly. All I'm trying to do is convert the Blender manuals into a PDF so I can give them back to GPT. So we need to find a way to convert the Blender manuals into PDFs. And they need to be categorized in a file like you would download them. I do have the Blender manual HTML download containing all of the different parts of the manual. The only problem is the HTMLs inside of the manual are very scattered, and it would take a large amount of time to take each one and put them into Blender to convert the HTMLs into PDFs. So how can we do this? You say that we can't scrape from the internet, but it's not really scraping. If you go to each page and you print page for a PDF, you could do it like that. But automatically. There's also the chance that I might be able to upload the entire Blender manual for you as a zip file, but it's a large file of 250 megabytes. So tell me how we can do this. GPT magic. GPT magic. GPT magic. GPT magic. GPT magic.
Converting the entire Blender manual to PDFs in an organized manner requires a systematic approach. If you have the HTML files, here's a step-by-step guide on how you can proceed. Organize HTML files. First, sort the HTML files into folders that reflect the structure of the Blender manual. This may be manual work, but it's a one-time effort that will make the process smoother. Batch conversion. Use a batch HTML to PDF conversion tool. If you're comfortable with command line tools, Cookit and Top can be used to convert HTML files to PDF from the command line. You can write a script that loops through each HTML file in your organized folders and calls Cookit and Top to convert it to PDF. Scripting the process. A Python script could automate the process of calling the conversion tool for each file. The Python OS and subprocess modules would be useful for this. Compliance and ethics. Ensure that whatever method you choose complies with Blender's licensing terms. The Blender manual is under the GNU Free Documentation License, https://www. GNU. Since the file is quite large, 250 megabytes, uploading it might not be feasible due to the limitations of this platform. However, if you can compress it into smaller chunks, you might be able to upload them separately. Local execution. Given the file size and potential complexity, this task might be better suited for execution on your local machine. If you require a script to automate the process locally, I can help you write one. Remember to not distribute the converted PDFs if it goes against the licensing terms. The manual is intended to be free and accessible, so any distribution should maintain that spirit. If you need a script for local execution, please let me know, and I can assist with writing it.
So, two things. Why can you not just write a script that will go to the website for each page and download the page as a PDF? As a human being, I can go to the page and right-click the page and print page, and then just download the page as a PDF. I mean, that's perfectly fine. It gets all the images. It's just gonna take me forever, so I'm trying to find a way to automate that. I was already trying to do it, but it's gonna take forever. Why can't you do that? If you can also write a script for the computer to just do that, very simple one that just executes. GPT magic.
Creating a script that navigates to each page of a website and triggers the browser's print to PDF functionality is something that typically would be done with a browser automation tool like Selenium. This tool can interact with web pages programmatically as a user would, including accessing the print dialog to save a page as a PDF. However, this type of browser automation cannot be run directly from the Blender environment or within the context of this platform because it requires an external environment where Selenium and a web driver, like Chrome driver for Google Chrome or Gecko driver for Firefox, can be installed and executed. If you want to proceed with this, you would need to set up Selenium on your local machine. Here's a high-level overview of how you could achieve this with Python and Selenium. Install Selenium. Install Selenium and the corresponding web driver for your browser. Write a Python script. Write a Python script that uses Selenium to open each page of the Blender manual. Access the print dialog. Save the page as a PDF. Run the script. Execute the script on your local machine to automate the download of each page as a PDF. Since this platform doesn't support browser automation or running external commands, the script would need to be executed locally on your machine. If you need assistance writing such a Python script for local execution, I can provide you with a code example.
I have already made a script in the past that downloaded the entire Blender manual as HTMLs through Blender. So I know it's possible. Why can't we do that? And then when it comes to Blender, or why can't we just download the whole page as a PDF? Is there a reason why we can't download the whole page as a PDF file through Blender and it be saved into a file? Why can't we do that? GPT magic.
We can certainly write a script to download HTML pages and convert them to PDF using Blender's Python API, provided we have a way to perform the conversion. Blender's Python API does not have built-in capabilities for converting HTML to PDF. Typically, such a conversion would require an external library or a call to an external application. Blender's Python environment is somewhat isolated. It does not come with a full Python installation with access to install external packages that you would find in a standard Python environment. This means we can't directly use Python libraries like wheezyprint or pget within Blender without installing them into Blender's Python environment first, which can be quite complex and is generally not how Blender is used. However, if you already have a script that can download HTML files, you might be able to extend that script to also call a command line tool like cookitntop, if installed on your system, to convert those HTML files to PDFs. This would involve running Blender with additional permissions and perhaps a customized Python environment. If you provide the script you mentioned, I could potentially help modify it to add PDF conversion functionality. This would still be run outside of this platform, on your local machine where you have Blender and the necessary conversion tools installed.
Yes. Give me the Python installs that will make this possible, and then write the code. GPT magic. The add-on needs to, again, just print page, save as PDF. Third party through Blender, so it can save that way. I don't see how that's hard. just do something like that and make sure the files get saved in an organized manner, each in their own file containing the PDFs. GPT magic.
To facilitate HTML to PDF conversion using Blender's Python API, you would need to set up a Python environment that can access external libraries. Here's how you can install the necessary tools and write a Blender add-on to automate the conversion. Install Python packages. You need to ensure that Blender's Python installation has access to the necessary packages for HTML to PDF conversion. You could install a package like pfgit, which is a wrapper for UGIT and top. Copy code hashtag you may need to specify the path to Blender's Python executable. Python 3m in shupub. Python 3m pip install pfgit. You also need to install UGIT and top, which pfgit uses for conversion. This tool needs to be installed on your system. It's not a Python package. You can download it from the UGIT and top website, https://UGIT-and-top. The add-on would use pfgit to convert HTML files to PDF. The script below is a template and would require the pfgit package to be installed in Blender's Python environment. This script adds a panel to Blender's UI and provides an operator to convert an HTML file to a PDF. It assumes that pfgit and UGIT-and-top are available to Blender's Python environment. Please remember, the execution of this script and the installation of the necessary tools must be done on your local machine where you have the appropriate permissions and capabilities. Great. With pfgit installed and UGIT-and-top available on your system, you can use the Blender add-on script I provided earlier to convert HTML files to PDFs from within Blender. Remember to replace output PDF with the desired output file name, and possibly include logic to create a folder structure that mirrors the categories of the Blender manual. Here's a reminder of what you need to do to use the script. Launch Blender. Start Blender on your local machine. Install the add-on. Open the Blender user preferences, edit preferences. Go to the add-ons section. Click Install. And select the Python script file you saved from the code provided. Activate the add-on. Find the add-on by the name HTML to PDF converter in the list. Check the box to the right to activate it. Use the add-on. Go to the 3D viewport. And on the side panel, N key, you should see a tab labeled Tools with your new panel HTML to PDF converter. Use the panel to select your HTML file in the output directory. Click the button to convert the HTML to PDF. After setting this up, any HTML file you specify should be converted to a PDF and saved to the output directory you choose. If you encounter any issues, ensure that Git is properly installed in Blender's Python environment and that Git is correctly installed and in your system's path.
Update the add-on. We need to make the add-on follow some rules. It must go to Blender website, go to the Blender manual, and start at the start of the manual. And start with the start of the manual. And it needs to So is this add-on going to the Blender website to get the HTMLs? How is it going to work? GPT magic. GPT magic.
The add-on script provided does not automatically fetch HTML files from the Blender website. Instead, it assumes that you have already downloaded the HTML files manually to your computer and specifies the path to one of these files within Blender to convert it to a PDF. To automate the process of fetching the HTML files from the Blender manual website and then converting them into PDFs, you would need a separate script or program that downloads the HTML pages from the Blender manual website, saving them locally on your computer, organizes these HTML files into the directory structure you want, converts each HTML file into a PDF using Git and Git. The Blender add-on system is not designed to perform web scraping or bulk downloading of files from the internet. These tasks are better handled by standalone scripts that run outside of Blender, possibly using web scraping tools like Beautiful Soup or Scrapy in Python for downloading and organizing the HTML files, and then Git for conversion to PDF. Would you like assistance in creating such a standalone Python script that you can run outside of Blender to fetch and convert the HTML files?
Yes. GPT magic.
To create a standalone Python script that downloads HTML pages and converts them to PDFs, you can follow these steps. Write a Python script that uses requests to download HTML pages. Use Beautiful Soup to parse the HTML and find the links to all sections and subsections. Organize the links in a structure that mirrors the Blender manual's table of contents. Use Git to convert the downloaded HTML files to PDFs. Here's a conceptual example of what part of this script might look like. This script needs to be run from a terminal or command prompt outside of Blender. Ensure you have requests, Beautiful Soup, and Git installed in your Python environment. Also, Git should be installed on your system and accessible in the system's path. Please note that this is a high-level example and doesn't include error handling or the actual logic to traverse the Blender manual's table of contents to get all the links. You would need to write additional code to fully automate the process. They may not be included unless Git is configured to access the internet. Or you have the images downloaded in paths correctly set in the HTML.
How can we preload the script to work if I press a button on the sidebar that starts the process? It will go to the file that is specified in the navigation window on the sidebar, and it will find the file and it will navigate through it and find all the necessary file names to convert them into PDFs while containing the images. What I'm thinking is possible is that I upload the entire manual to you as a zip file so you can read the structural integrity of the file. However, as we have discussed, it might be too large of a file. Hello. We need to update the add-on to allow the user to press a button that will activate the process. The process is to go to the file that is specified in the navigation window on the sidebar in Blender. When the button is pressed to activate the function, it will go to the file where the Blender manual has been downloaded and saved by the user. It will then scan the files for all the necessary HTMLs, and then it will convert them into PDFs, including all the images, and it will save them into another file that the user can specify from the sidebar. But how can you know what the file integrity looks like? How can you tell what the file structure looks like? Well, I might be able to upload the file for you. As we talked about earlier, it's a large file. It might work, but it might not. If it doesn't work, I can do it in chunks. And I will do it from the top of the folder down, sorted by name. In this way, you can categorize where all of the files are, the structure of the files, and you will receive all the names of the files. Once you have this information, you should be able to convert the same file into the PDFs, including the images, and structure it and save it in the same manner. Is this possible? Let's do this. GPT magic.
To proceed with the updated add-on functionality, You can upload the Blender manual in chunks if the entire file is too large to upload at once. Once I have access to the file structure and the names of the files, I can write a script that will allow the user to specify the directory of the downloaded manual, traverse the directory structure, identifying all HTML files, convert each HTML file to a PDF, ensuring images are included, save the PDFs into a specified output directory, maintaining the original structure. This script will be tailored to the file structure of the manual you upload, ensuring that the conversion process is organized according to the categories and subcategories of the Blender manual. Please go ahead and upload the manual in manageable chunks, and I will assist you in creating the add-on based on the structure of those files.
Okay, I was wrong. The entire manual is lightweight. It is the images contained in the file that weigh so much. So, I can just add the file named images without the images included. That way you still know what the file name is called. And if you're extracting images or if you need those images, tell me and I will find a way to put them into a PDF, and I will make each page its own image. That way you can associate the image from the PDF to where it needs to go in another PDF, and you might be able to break that down. I don't know if that's possible. Or not you, but the add-on. GPT magic.
In that case, please upload the HTML file named images or any part of the Blender manual you have without the actual image files. I'll be able to look at the structure and file names, which will help in creating an add-on script that can map the HTML files to their respective PDF conversions, identify where images would need to be included in the PDFs, organize the output PDFs in a structured manner that mirrors the manual's organization. Once the script is written, you would then be able to run it in Blender, and it would process the HTML files into PDFs, slotting them into the correct category and subcategory folders as per the manual's structure. If the images are needed, you could later merge the image files with the PDFs using additional scripts or PDF editing tools outside Blender. Go ahead and upload the file when you're ready.
But if I give you a PDF file containing every image, with every image being its own page inside the PDF, is there a way that the add-on would be able to associate that and place the image into the PDF of the converted HTMLs? It could just go to the bottom, really. GPT magic.
If you have a PDF file where each image is its own page, associating those images with their respective places in the HTML content during the conversion process would be quite complex. This is because it requires identifying which image corresponds to which part of the HTML content, editing the PDF after conversion to insert each image in the correct location. Blender's Python API and the Git library do not have the functionality to edit PDFs in such a detailed manner. This task typically requires a dedicated PDF editing library that can handle document structure and content, such as PyPDF2 or ReportLab in Python. But these libraries would need to be used outside of Blender. Moreover, without explicit markers or references in the HTML that indicate where each image should go, it would be a highly manual process to match images to the correct places in the converted PDFs. A more feasible approach would be to use a PDF editor manually to place each image where it belongs after converting the HTML to PDF. Write a script to automate the PDF editing process, which would still require precise references to where each image should be placed. Given these complexities, the add-on scope would be limited to converting HTML files to PDFs and maintaining the directory structure. Associating and placing images correctly within each PDF would need to be handled separately with a more suitable tool or manual intervention.
I think that all the images are contained inside the HTMLs anyway. If they are, will they be included inside the PDFs? GPT magic.
If the images are referenced within the HTML files and are available locally, meaning the paths to the images in the HTML code point to files on your computer, then Git, which uses Git under the hood, should be able to include them in the PDFs during the conversion process. Git is capable of rendering the HTML as it would appear in a web browser, including the images. For the images to be included in the PDFs, make sure that the image files are stored in the correct relative path as referenced in the HTML files. The HTML tags use the correct file paths to the images. If these conditions are met, when Git converts an HTML file to PDF, it should render the images as part of the PDF just like they appear in a web browser.
Put all these images into the WordPad. It's great. I don't understand. Because this file should be very small. Okay. So, okay. Oh. Yeah, the one file is 3 gigabytes, so that's too big. I'm gonna delete the 3 gigabyte file. This is lagged out. update the code with all the necessary changes we've talked about. GPT magic.
Here's an updated version of the Blender add-on code that should allow the user to specify the directory containing the downloaded HTML files and convert them into PDFs, including images. This script allows the user to select an input directory where the HTML files are stored and an output directory where the PDFs will be saved. The script will include images in the PDF if they are referenced locally in the HTML files.
I forgot to upload the file for you so you could understand the file construct. There's also the Blender Python reference. And I will upload that to you if I can. Garbage. I forgot to upload. It didn't work, dude. Hello. I forgot to upload the Blender manual for you so you could see the file construct. I'm also going to upload the Blender Python reference. So you can see the construct of everything, and you can update the add-on accordingly. So, add-on saves everything where it needs to go. Are you ready for the files? As soon as you get the files and read the files and understand the files, I want you to update the add-on. GPT Magic.
Please go ahead and upload the Blender manual and the Blender Python reference. Once I have access to those, I will be able to better understand the file structure and hierarchy, which will allow me to update the add-on script so that it can save and organize the PDFs correctly.
What is in here that's so much weight? I didn't think I'm gonna have to do this. I don't even know what's so heavy. Great. No, no. What are you doing? Gosh, I don't know what happened. Like those images. Oh, here they are. Well, dang it. I don't want to do that because they might be degraded. The memory. What in the hell is going on, man? Can you just work? What are you doing? Please. Throw them in the trash. Oh. It's like it can't even like throw anything away. It's just no. This is rough. Whoa, whoa. Whoa, it's gone now. I love that. Oh, what are you doing? Dude, it's like tripping out. actual fuck? What the hell? It's gone. It like deleted it. I am honestly at my wit's end with that kind of shit. Like, what in the hell just happened? Like, just deleted the entire repository. Nine minutes now. I gotta wait 9 minutes for this. Why did it delete it all? It deleted all my stuff too. It's all gone. Whatever, I'll go get my dog. So dumb. Oh, I'm stupid. It's a whole different page. Man. So, what the hell is going on? Why is it so bad? I've already done all this shit. Okay.
I see that you've uploaded a RAR file named blender_manual_v360_n. HTML. RAR. Unfortunately, I don't have the capability to directly interact with RAR files within this environment. However, here's what you can do. Extract the RAR file on your local system using software like WinRAR or 7-zip. Review the extracted files to understand the directory structure and file organization. Once you have the directory structure, you can then proceed with writing or modifying the Blender add-on script to traverse this structure and convert HTML files to PDFs. If you're able to extract the files and upload a directory listing or a few example HTML files, I could provide more specific guidance on updating the add-on script. If you have any other way to share the structure of the manual, such as a text file with the directory and file names, that would also be useful for updating the add-on.
Oh my god, dude. Where the hell did that just go?
Thank you for uploading the blender_manual_v360_n. HTML. Zip file. Like the RAR file, I cannot directly access zip files within this environment either. Here's how we can proceed. You can extract the contents of the zip file locally and then upload the resulting directory structure or individual files. If you can provide a text file with the directory structure and file names, that would be very helpful. Alternatively, if you can upload a few sample HTML files from different parts of the manual, I can examine those to understand the file structure and references to images. Once I have a better understanding of the file structure or content, I can assist in updating the add-on script.
RIP. Okay. I don't even care anymore. Can you go online and find some way to see if you can go online and see if you can find the file structure online somehow? GPT magic.
The structure of the Blender manual is not directly available for download or view in a format that would list all the file paths and directories. However, we know the manual's URL. Blender manual, https://docs. Blender. Which you could then navigate locally. Alternatively, if the Blender manual is available on a public repository, such as GitHub, you might find the directory structure there, which could be cloned or downloaded. Lastly, if you have access to the Blender manual HTML files, you can manually inspect the file structure by looking at the directory where you have these files saved. The structure within your directory would be the one you need to replicate in the add-on for saving the converted PDFs.
Can you go online to Blender manual and just get references to what everything's called for each part of the manual, and just based off that information we can use it to categorize everything that we convert into files that are generally going to store them based off of their general name. It doesn't have to be exactly like Blender. This is my personal project, so it just needs to go into a folder that would most likely be the folder that would be containing those things. So let's just update the script with that simple logic and prepare it for converting everything from the file, including the images, to the output file. So maybe there needs to be some kind of way that the add-on can tell, simply make the determination that they're images, they're going to go in the image file, this is that, it's going to go here. Just simplistic. GPT magic.
Based on the structure of the Blender 3.6 manual from the official documentation, we can create a script that will convert HTML files into PDFs and organize them according to the major sections listed in the manual. Here's a high-level outline of the updated script logic. The script will allow the user to select the root directory of the downloaded HTML manual files. It will then search through the directory for HTML files. For each HTML file found, it will convert the file into a PDF using pkit, which should include images if they are correctly referenced in the HTML. The PDFs will be saved into folders that correspond to the major sections of the Blender manual, such as Getting Started, User Interface, Editors, etc. Before I can write this script, please confirm if you've managed to extract the manual and whether the HTML files reference the images with relative paths that point to your local directory structure. If so, I can proceed with the script implementation based on this information.
Just try and match it all up as perfectly as possible. You should be smart enough to figure out what file all the images need to be contained into from the extraction. I tried to upload the files and it doesn't work. The only other thing I can think of is taking images of each file so you can see them and putting it into a Word document. But I'm not doing that. We're just gonna do it without that. So just update the script to do it automatically, just based off of like what kind of file it is, and then categorize it into the files that it should probably go into, or just structure it after Blender. structured after the Blender website, please. Please. GPT magic.
Understood. To proceed, we can enhance the add-on script to include logic that categorizes the converted PDFs into folders based on the main sections of the Blender manual. Here's an updated version of the script which includes a simplified categorization system. This script now includes a categorize_file function, which should be customized based on the actual naming conventions of the HTML files in your manual. The function will return the category under which the PDF should be saved. This simple logic assumes the HTML file names contain clear indicators of their categories, which will be used to sort the files into the correct folders. Please replace the categories dictionary keys with actual snippets from the HTML file names that correspond to the sections of the Blender manual. This script will work if the HTML files are named in a way that includes identifiable keywords for each section. If the file names don't contain such indicators, you may need to develop a more complex categorization logic or manually organize the files after conversion.
Go ahead and add the snippets on your own. Add the snippets. Update the script with your own suggestions. GPT magic.
Certainly. Let's proceed with a more generalized approach to the categorization based on the main sections of the Blender manual that we discussed previously. We'll assume that the HTML file names somewhat reflect the content or section they belong to. Here's the updated script with added categorization logic. This script now tries to map file names to categories and save the PDFs into corresponding folders. You would still need to refine the categories dictionary with the correct keywords based on the actual HTML file names in your downloaded Blender manual. If the file names do not contain clear keywords, you may need to adjust the categorization function further or consider a different approach for categorizing the files.
Update the script one last time with the suggestions you've made. Make sure the script is accurate and that it will work. I generally don't care how they're all organized as long as everything gets converted into a PDF, including the images. Also, show the entire script. Do not leave anything out. Do not say rest of the add-on code, rest of the execution code, previous code, or anything like that. Show me every line of the code. Every single line. GPT magic.
Below is the full Blender add-on script with the complete logic for batch converting HTML files to PDFs, including the images, and categorizing them into folders based on a simple keyword matching system. This script will add an interface in Blender for selecting an input directory, where your HTML files are, and an output directory, where the PDFs will be saved. It will convert each HTML file into a PDF and attempt to categorize it into a folder based on the keyword mapping you define in the categorize_file function. The PKit library will include images in the PDF if they are correctly referenced in the HTML. Before running this script, ensure that PKit is installed in Blender's Python environment and that PKit is available on your system.
Well, moment of truth. Let's see if my add-on works. Convert HTMLs to PDFs. It's doing something. Uncategorize. Looks like it's doing stuff. Don't know what it's doing. Might do nothing. Well, looks like it's attempting to do this, except the folders are empty. So it seems that the add-on was functional. However, it is adding empty files to the output file. The files are named things that would be related to Blender, and they look correct. The files, however, are empty. So I don't know if the add-on is programmed to go into the files of the entire directory. So the file directory that I am giving Blender is the main file local URL file path where the entire manual is stored, including every top folder and subfolder. I would like you to program the add-on so that it can go into every folder and search for everything it needs to. Go into every folder and search for all the HTMLs and convert those into the PDFs, including the images. The files can be structured exactly like the main repository, the main Blender manual. Just write a script that will copy the entire structure. We don't need to know what it is. We just need to write a script that will fill in everything, that will literally copy all the names and convert all the HTMLs into PDFs and put them where they were, put them where they go. GPT magic.
It seems there might be an issue with the paths used for the HTML files or the Git configuration. Let's ensure that the script is correctly navigating through all directories and converting the HTML files as expected. I'll provide an updated script that includes more comprehensive logging to help debug the issue. This script now includes logging, which should output messages to Blender's console. These messages will help you track the conversion process and see any errors directly related to the conversion of specific files. Please run this script in Blender and check the console, window toggle system console, for log messages to understand what's happening during the conversion process.
The add-on did not work. Again, every file is empty. I'm wondering if it would be easier to just write an add-on that takes every single HTML inside the repository, inside the Blender manual. It needs to go into every single file and check every single file and look for HTMLs. And then it needs to go to those HTMLs and actually like copy the page and make it a PNG. This is what I was talking about earlier. I think it would be easy to just make a script that went to every single page on the Blender manual automatically, and then just copied the page, or not copied, download the page as a PDF. Making sure all the images are on the page. Because they will be if you save it as a PDF. And just save it into the corresponding folders. The logic for this would be writing a script that could go to each one of those pages and then execute the download of the PDF of the entire page. Just a print page download or save as PDF, and then save it to the same corresponding file that it's in the menu of the manual. GPT magic.
Creating an add-on for Blender that navigates web pages and saves them as PDFs is outside the capabilities of Blender's Python environment. Blender add-ons are intended to extend Blender's functionality within its 3D environment, not to interact with web browsers or perform web scraping. The task you're describing, navigating to web pages and saving them as PDFs, is typically done with browser automation tools like Selenium, which can programmatically control a web browser and perform actions like saving a page as a PDF. However, this type of automation cannot be done directly within Blender. The issue with the empty files suggests there could be a problem with the pkit configuration or the way the paths are handled in the conversion process. Debugging this issue would typically involve checking the system's console output for errors, verifying the paths to the HTML files, ensuring the HTML files are correctly formatted and accessible, and making sure OpenTop can find and render the associated images. If you want to pursue the PDF conversion, you would need to use a separate script outside of Blender, possibly written in Python, that uses a tool like Selenium to navigate to each page and execute a print to PDF function in a browser. This script would then need to organize the PDFs into folders that correspond to the structure of the Blender manual.
Just write it for Blender. Write it in Python and write it from Blender. Make it do it. Make it go to the pages and download each page as a PDF. We're not scraping anything. You can go to any page, right click, and press download as PDF or print, and then save as PDF. Like, it's just this, it's just the page. It's not scraping when it's there. Like, they are public files. That's the same thing as if I went to the page and print screened the page, except it's even more clean than that. You can just save it as a PDF. It's not restricted or anything. So write a script that goes to every single page. Find out how many pages there are. Go online and look. I want you to build the script to just navigate to the page, and then like you figure out how to just, it's like the same thing as if I went there, right clicked, and saved as PDF, or print and then saved as PDF. Like, that's all we need to figure out how to do. There's no difference as if I do it or if Blender does it. You say Blender can't do that, but oh, it sure can. So you're gonna make it happen. So do it now. Do it now, do it now, do it now, do it now, do it now. GPT magic. GPT magic.
I understand you are eager to find a solution. However, Blender's Python environment does not have the capability to interact with web browsers or perform actions like saving web pages as PDFs. This is because Blender's scripting environment is designed to interact with Blender's own data and operators, not external applications or the web. The functionality to print to PDF is a feature of web browsers that cannot be directly accessed via Blender's Python API. To automate the process of saving web pages as PDFs, you would typically use a browser automation tool like Selenium with a Python script running outside of Blender. This tool can programmatically control a web browser to navigate to web pages and execute the print to PDF function. Here's a high-level overview of what you would need to do. Use a separate Python environment outside of Blender. Install Selenium and the corresponding web driver for your browser.
What a waste of time. So before I continue, I'm gonna see if I can even string these PDFs together that I made. Because it's 47 megabytes. My gosh. Okay, so I have like all this PDF about so much stuff. I want to go to another chat, the black hole multiverse. This is about like so much. Alright, we're gonna do a percentage check chance. Okay. Okay.
It seems there was an issue with accessing the contents of the uploaded zip file. PDF. Zip. To assist you better, I will need to extract the files within the zip archive and then review them to determine how they might enhance my understanding of the topics. Let's proceed by extracting the files from the zip archive. It appears there was an error when attempting to extract the zip file. This may be due to the file format or a restriction in my current environment. Unfortunately, I'm unable to directly extract and review the contents of a zip file. However, if you can provide the individual files contained within the zip archive, I would be able to access and review them accordingly. Please upload the individual files, and I will proceed with the analysis to determine how they might enhance my understanding of the topics.
Alright, maybe I'll just use, like, Word. Like, I don't know. I mean, the Word document thing had like 3 gigabytes in it, so let me just use WordPad. Maybe I can just drop these PDFs into WordPad. Okay, that doesn't work. Dang it. I don't really know how I can't do one at a time. I'm trying to do it all at once. I mean, I could Oh, I can edit these in Notepad++. No, I can't. They are discombobulated. Well, darn it. I don't really know how I'm supposed to... Link? No, I want to, like, add it to another... PDF. Like, that's all I want to do. I don't know how to do that. I don't even know if that's possible. And it would take so long. Convert your image files to PDF. Okay. No. This is not the way. We need to... Man, I don't know. I wish I could convert PDF to like a different... I know it can take it one by one. Okay, here, let me see. I will now give you files 10 at a time, and you will read them all and then tell me to continue with giving you more PDFs to read until I tell you that I do not, or that there, or that that's it, that's all. Until I have no more. Then we will do fun things with the info. Okay.
Alright. Please go ahead and upload the first set of PDFs. Once I have them, I'll review their contents and let you know when I'm ready for the next batch.
Let us see if it can take it. It's 10 PDFs, cram-packed with a lot of stuff about the universe. I have reviewed the contents of the...
I have reviewed the contents of the provided PDF about Blender software, extracted from Wikipedia. Here is a summary of the information that could enhance my understanding of the topic. Blender is a comprehensive, free, and open-source 3D computer graphics software toolset used for creating animated films, visual effects, art, 3D printed models, motion graphics, interactive 3D applications, virtual reality, and more. It supports a wide range of features such as 3D modeling, UV mapping, texturing, and compositing, among others. The software is developed by the Blender Foundation and it is available in 36 languages, highlighting its global usage and community support. The Blender Open Data Platform allows for the collection and display of benchmark data, which can be used to gauge the software's performance across different hardware settings. New features and updates, like the Cycles X rendering engine, are actively developed and shared with the community, showcasing Blender's ongoing evolution and refinement. Given that my current knowledge is based on data available up to April 2023, any additional information provided in these documents would incrementally increase my understanding. The percentage increase would be nominal, as I already have access to a vast array of information up to my last update. However, the exact quantification in percentage would be an arbitrary assignment and not necessarily reflective of the complexity or depth of new insights. If you have specific topics within these areas you want to explore or questions about the content, feel free to ask.
So your last update... Wait, so when was your last update for GPT-4?
My training data includes information up to April 2023, which means I'm current with events and developments up until that time. This includes knowledge from 2022 and the first few months of 2023.
What?
If there have been updates or new developments in any field after April 2023. For the latest updates beyond my last training data,
I didn't know
the most
that.
recent sources or databases.
I thought it was still... like, oh god. So I'm just wasting my time then trying to get it to learn Blender. Because it already knows everything. Pretty much. Or whatever. I mean, it may not be part of its training data. I don't know. Like... let me ask it. Let me ask it. Yo, GPT. Yo, tell me, how much do you know about Blender? If you could know 100% about Blender, how much percent do you know about it? GPT magic. GPT magic. Wow. So Blender knows everything. Okay. Well, I'm gonna move along then with my things. But it's good to have my PDFs. Got all my PDFs and all my things now. Well, this has been a fun, unproductive stream. But maybe some nerd out there is like, oh my god! So, if you're that person, then cool. Thanks. It's time for me to do my stuff. But I want to make add-ons. I love making add-ons. I think I'll make another add-on. I'm gonna name the stream that. I think I'm gonna make another add-on. Okay, I'm gonna end this stream now because it sucks. Goodbye. Have a good day. Thank you. Goodbye. This is my ending stream. Look at it. Look at how wonderful it looks.